Well, hello there and welcome. This is Aurora with Supercharged Math, and I am super excited that we get to spend this time together. So I know we're about 4 minutes out. We haven't officially started yet, but that's okay. I wanted to let you know what we're going to be doing, and then make sure you have all the resources that you need. Okay, so for today, we are going to be spending some time in both fractions and decimals, and then wrapping it up with a little bit of percent. We're going to introduce the idea of percent and wrap it together with fractions and decimals so you can see how they relate together. We're going to be doing hands-on applications of both, and we are also going to do some math challenges. So I am super excited for today. So what do you need? You need a pencil and a piece of paper. Now, if you happen to get the email, I'm sorry, the email service provider we use, I think, botched it and didn't send everybody the email, the reminder for today and the worksheet. So if that happened to you, I'm really sorry. All you need is a piece of paper and a pencil, and you just write down what I write down. That's easy. In fact, when I teach my regular math classes, that's what the students do. So I'll say, okay, get out your math journal, and that's exactly what they do. Okay, if you do happen to have the workbook, let me show you what it is. I'll make sure that you have access to this after class as well, okay? And so this is the 18-page workbook I put together with you, or for you, and there's quite a bit of information missing. So if you started to work on it, just wait until I give you more information during class, because some stuff you won't even know what to do. Like there's a map of the United States in there, and there's no instructions for what to do with that. So we're going to go through this whole workbook step by step. Okay, and so it says here what we're going to cover, and then it also has down at the bottom, our goal is for you to have fun with this class, learn something new, and you know and understand how to use math in the real world. And that's my goal for today. So my goal isn't to cram as much math as I possibly can at you. It's just to focus on a few of the fundamentals. So everyone take a deep breath. And then do those really well. So we're going to introduce fractions. I'm going to do some basic operations, and we're going to roll right into a practical application. And then we're going to have a challenge. We're going to get up and do something. I have a physical challenge, and then I'll give you time with the challenge, and then we're going to come back. If you would like to do the decimal part, you're welcome to do that. If not, if you want to continue still working on fractions with the workbook and the challenge that I mentioned, that's fine. Feel free to do that. I will make sure you have a replay to the entire class when we're all done. So you could do this at your own pace. So everyone smile. Yay, right? Okay, and then I'm already getting questions. So let me finish outlining it. And so we're going to spend some time with fractions. We're going to do a practical application, and then you're going to have a challenge. And we're going to take a quick break, and then we're going to do introduction to decimals. And then we are going to do the basic operations with decimals, and then we are going to have a practical application. And then we're going to have challenge number 2. All right, and then we're going to come together for really, really quick. It's going to only be 5 or 10 minutes. We're going to talk about percent. We're going to talk about how they relate fractions and decimals together. And then I will make sure that you have the answer key to the whole thing. So today's class, my guess is about 75 minutes. And if that's too long, that's all 3 parts put together. So that's fine. You're going to take lots of breaks. You're going to get up. You're going to walk around. You're going to have some fun. I will make sure you have the entire thing available to you as a replay after the class is over. So you don't feel rushed. You do this at your own pace on your own schedule. And so, yes, the person asking for the answer keys, that will be provided after class, because I'm going to take photographs of what I'm writing down so you have exactly the same thing. Okay, so, all right, so you guys ready to get started? So hello and welcome. This is Aurora with Supercharged Math, and I want to personally welcome you to my math class that we're going to be doing today. We're going to introduce fractions, we're going to introduce decimals, and then we're going to take a look at the link between fractions and decimals and roll that into a little discussion about percent. This class is packed full of activity. So we're going to focus on what a fraction is, how those numbers are built, and then we're going to look at how we do basic operations, and then we're going to have a practical application. Then we'll do the same thing with decimals, and then we'll do the same thing with percent. So this is supposed to be fun. You're supposed to have a good time with it. So shake your body out, put a big smile on your face, because we are ready to get started. If during class, at any time, you have questions, you are just going to submit them. I'm going to answer those questions as I can as we work through this our class together. This is your time. So I want to know what you know and what your challenges are, what your struggles are, so I can help you in that area. This class is actually a part of my really big program called Supercharged Math, and it's brand new this year, still putting it together. We have about 750 videos as of today that are posted on it. This is a sample from that program. So if you like this and you want more, there'll be an opportunity to learn about that later. For right now, I would like you to put a big old smile on your face, grab your pencil, and I'm going to take you down to my desk, which is going to have a copy of this. I'm going to put this down on my desk. Whatever I'm writing down, you guys write down too, okay? And I will also want you to shout out the answers. So pretend like I'm sitting in front of you. You and I are having a conversation about math, and I'm asking you questions. You're shouting back answers. You're shouting answers at me, and type them in so I can get them as well. All right? And then at the end of class, I am actually going to be giving away 2 prizes to 2 students that are in class today, a math prize. You're really going to like it. I'm going to tell you more about that during the break. But for now, let's get to work on fractions, shouldn't we? Okay, if I were to ask you, what is a fraction? What would you tell me? Okay, don't make it too complicated. Imagine I'm in I'm like 8 or 9 years old. You tell me, what is a fraction? And I will read out some of your answers as I am setting up my slides here. Okay, so go ahead and tell me some of the answers. Okay, good. Some part of a number. Hey, that's great. What else are you seeing? What is a fraction? What is a fraction? Okay, so what is a fraction? So I'm skipping ahead. This is page 1. Materials are on page 2. You don't need a lot of materials. Okay, so skip ahead to page 3. All right, so fractions, and let me bring the camera down just a smidge here, just so you can see a little bit. Oh, that's probably a little too close. All right, how does that look? Does that look good? Okay, so fractions, and do you see where it says fractions at the very top? Okay, so fractions are part of a whole. I want you to write the word whole in here. Okay, fractions are part of a whole. Okay, what does that mean? So we have a fraction here. We have one number, a line, and another number. The one on the bottom, this is how many make a whole. So if I have 4 of them, then I have a whole unit. And it could be a whole of anything, right? It could be a batch of muffins. It could be how many cakes fit into your car. That would be a whole unit, right? 3 is how many we have. How many we have. Okay, I am doing this with Sharpie, not pencil, so it will show up better on the video. You should be using pencil when you do your notes and when you do math in general. Always a good idea. Okay, all right, so if I'm saying 4 makes a whole, look at this, 1, 2, 3, 4. So this unit, this circle with the little crosshairs in it, that is a whole. If I say I've got 3/4 of a circle, what does that mean? That means I've divided my circle into 4 parts, and I've got 1, 2, 3. Okay, so 3 is shaded out of 4. Does it have to be a circle or a pizza? No, it doesn't. It could be one of these. It could be a candy bar. You guys like candy bars? So imagine you've got one and you slice it into 4. The important part here is that the size of the divisions is equal for each one. You can't have a giant piece and a tiny piece, right? Imagine doing that with a kid. Yeah, they're not gonna be too happy, right? So all of your divisions have to be the same shape and same size. They have to have the same amount of stuff. So I can take my candy bar and split it into 4s. 3/4 is gonna be 1, 2, and 3. Okay, I can shade, this is how many we have. I ate 3 out of how many? How many possible is on the bottom? That's how many make a whole. 1, 2, 3, 4. This makes 1 candy bar. I split it into 4 equal pieces, and I eat 3 of them. Okay, so I ate 3/4, and now I'm not feeling so good. How are we doing so far? Okay, so let's take this a little bit further. Do you see the pictures on the bottom here? Okay, so let's take a look. We're gonna color our own, but before you start doing that, because your fractions will be different than mine, I want you to go like this. Can you put a line under each one? Can you go like this? Okay, so what I want you to do is this. On the bottom, remember, this is how many make a whole. I want you to count them up. This one is 1, 2. That's the bottom number, also known as your denominator, okay? Denominator is like a dungeon. It's on the bottom, okay? So there's 2 possible. Now, what about this one? There's 4 possible, right? 1, 2, 3, 4, just like we had up here, right? 4 possible, so you're gonna write that at the bottom, okay? What about this one? How many are in here? So when we get to these, sometimes it's a little hard to count them. So just start with a dot. 1, 2, 3. Just put dots in it. See? 6. Okay, I have 6. So that's 6 possible. So 6 slices make one whole pizza, right? All right, what about this one? How many are in here? Can you count them with me? 1, 2, 3, 4. Oh, I'm only counting 4, and notice that's a half. If I take 4 twice, 5, 6, 7, 8, I get 8, right? So there are 8 slices that make a whole unit. So this here is just 1 over 8. So this is in eighths. This is in sixths. It's so the number 6 with a th after it. How many are in here? There's a lot to count. So start with the dot and then go all the way around and tell me, how many do you have? Just shout it out when you know it. Okay? 10. There's more than 10, Amanda. So what do you have? Yeah, 12. That's right. There are 12 here. So 12 make a whole. All right. So now I want you to shade in as many as you want. So for this one, let's just shade in 1 because otherwise we've got the whole. There we go. So that's 1/2. All right. So shade in other amounts. Go ahead and do it. I'll give you just a second. And they don't have to be side by side. They can be so, okay? And however many you shade in goes on the top. Do you see that? Okay, so go ahead and shade a few of them in. You don't have to do them all. Just shade in the ones that you want. Okay? Doesn't have to be the same as mine. You just make your own. Make your own fractions. All right, so we got 1, 2. I'm only going to do 3 on this one. How many are you doing? Okay, maybe I'll use purple again. 1, 2, 3, 4, 5. Okay. All right, so you want something that looks like mine in that you've shaded it, and the number the number of sections you shaded is the same number that's on top. So do you have that? Okay, so go ahead and finish that up. Yeah, don't spend all day on this. We got a lot to do. Okay, I want you to notice something. All right, let's look at the 8 since I had highlighted that one. What would happen if you had gone in here and shaded all of them? Imagine I did all of them. Okay, I'm going to write that one down here. Okay, so the original was 3, but now I'm going to do a different one. Okay, 8 is still on the bottom. That doesn't change. But what's on the top? Well, I shaded all of them, so that I got to put an 8 on the top. Anytime you have a number over itself, that means 1, and that 1 means 1 unit. So if you order a pizza and you eat, and it had 8 slices and you eat all 8, you could say, I ate 1 pizza. If you made a dozen muffins and you ate 12 of them, 12 is a dozen, you could say, oh, I ate the whole thing. I ate 1. Okay, put a smile on your face if that kind of makes sense. All right, now watch this. If I have any number over itself and it's the same number, it's always going to be 1. 3 over 3 is 1. 1,000,000 over 1,000,000 is 1. So anytime I have a number over itself, it's always 1. Doesn't matter how big it is. Here, I'll put 1,000,000. It's always going to be 1 because why? This is the number of divisions on the bottom. This is how many make a whole. If you happen to have that many, now you have a whole. All right, so give me a smile so I know that this is working. Put a little smile on your face, yeah? Okay, so that is page number, this was page 3. This is the first page we're doing. Okay, so flip the page. I want you to take a look. Now we're on page number 4, okay? All right, so multiplying fractions. How do we multiply a fraction? Okay, so the easy way to do it is like this. I want you to write this with me. Okay, so let's just skip the sample. I'm actually going to show you how to do it. Write 2 over 5. So there's 5 divisions, and I ate 2 of them. Okay, or you ate 2 of them, okay? All right, and then I want you to write another one really close by. Can you do that for me? So write 2 over 5, and then 1 over 3. Okay, great. Now, can you put a little X between them? So this is our multiply sign, right? Now, I want you to take your hand and go like this. Take your hand and put it over that. So you only see 2 times 1. You tell me, what is 2 times 1 equal to? 2 times 1 is 2. Yeah, so you write that on top. And then you put the line. And now you take your hand and you move it and you go like this. What is 5 times 3? 5 times 3 is... That's right, 3 times 5 is the same. Good, good. Yeah, it's 15. And that's the answer. So anytime you multiplying fractions is easy. but you got to use the hand thing. So let's do another one. How about 3/4 times 2/3? Okay, so grab your hand, put it on the bottom. What is 3 times 2? 3 times 2 is 6. Now move your hand. What is 4 times 3? 4 times 3 is 12. Excellent. I'm getting this. Oh, I'm so glad, Eileen. Good job. Okay, let's do another one so you're comfortable. Okay. How about 6? Oh, you know what? Oh, wait. Hang on. You know how you erase things when you're doing math with a Sharpie? You put a sticker on it. There we go. All right. So I wanted to take a look at this a little bit closer. Okay. So let's say, for example, I have this here. Can you draw a circle next to it? And then put a big line through it and then another line like that. Can you do that for me? Okay, great. Now what I want you to do, this is going to take a little bit more work. Watch me first. I want you to draw 2 more lines. Can you do that? And then draw 2 more. Okay, it's okay if they're not perfect. And then draw 2 more. And then draw 2 more. Okay, got it? Okay. There are now 12, this is a circle that we had divided into 12 parts, just like we had here, right? So this is 12, and that's what's on the bottom. Can you color in 6 for me? Get your pencil out, color in 6. It could be any 6 that you want. You can alternate, you could do it like this. Okay. I'm gonna do it like this because I want to show you something really cool. Okay, so watch this. Let's work with this number, 6/12. Here, I'll move this up so you can just see that. Okay, so 6/12 is, what is 6? 6 is equal to 2 times 3. Would you agree? Okay. And, oh, that's a 12. And 12 is equal to 4 times 3. Is that right? Okay, take a look at what I have here. Look at this. Look at this. 3/3. Now, where have we seen that before? Where have we seen that before? I'll give you a hint. We did it on this page, kind of around here. What do you notice? What do you notice? Yeah, it equals 1, doesn't it? Can you tell me right now, if that equals 1, then what do we do with it? What do you think we do with it? Okay, that's right. We put a 1 here instead of a 3/3. We can make that a 1. So you could just put your finger over it because 1/1, we could multiply numbers by 1 all day long and nobody really cares. All right, so what do I have? I now have 2/4. So this thing turns into a 1. 2 times 1 is 2. 4 times 1 is 4. Okay, so I have a 2/4. So even though this is a 6/12, I can break it down into parts and make it even smaller. So what have I done here? Draw another picture. Draw another picture. Give me another circle with the little X, with the plus in it, just like that, okay? All right, and then what else do we do? Well, now we've got 4 divisions, 1, 2, 3, 4, okay? And now we're gonna color in 2. All right, so color in 2 of them. And then what do you notice? Take a look at this shape right here. This is exactly the same shape as this. Do you see how 6/12 is equivalent to 2 4s? They're exactly the same fraction. Yeah, we just multiplied it by something to get the numbers to be different, but what it means is exactly the same. And I see students already reducing it even more. Yes, yes, you're already ahead of me. Okay, so if I have this one, so we have 2/4, right? 2/4. 2 is equal to 2 times 1, right? It's just 2. And then 4 is 2 times 2. Okay, do you see the form of 1? That's right. Where is the form of 1? Here, I'll use a highlighter this time. 2/2. Okay, this works because it's multiplied. If it was added, you couldn't do this trick. All right, but it's because it's multiplied. You see 2/2, so this is going to become a 1. Do you see how that's a 1? That's a whole unit. Okay, so what do I have? I am left with 1, and I'm left with a 2. And then here, last picture. Draw one more circle. You're going to get good at circles. But now, only put 1 line through it. What did we do? We just took a circle. We divided it in half. And do you notice how the shape is the same? Yes. This is how we scale fractions. We'll take a half. We'll multiply it top and bottom by the same number, and we'll get different amounts of divisions. What are we doing? When I multiply 1/2 by 2/2, that's a form of 1, 2/2, I'm putting in one more division right here. I'm increasing the number of divisions when I'm multiplying this. So if I take 2 over 4 and I multiply the top and bottom by, say, 3 over 3, like we did here, now I'm going to get 2 times 3, which is 6, and 4 times 3, which is 12. This 3 simply means instead of 1 piece, there should be 3. Do you remember when we drew that up here? So we're increasing the number of divisions when we multiply top and bottom by the same number. This is a 1, we're multiplying it by 1, right? 3 over 3 is a whole, that's a 1. But the way it breaks into what it does is it scales the fraction up so we can add things a lot easier. So how does that look so far? I'm going to pause here for a second and see if we've got questions. This is a big deal, what we're talking about right now. Yeah, adding more divisions. That's right, that's right. Good job, Sam. We are adding more divisions. That's right. Every time we multiply by some form of 1, 10 over 10, 3 over 3, 2 over 2. For 2 over 2, when what we're doing is we're saying instead of 1, we want 2 divisions. Okay, so we had 1, but if we multiply by 2 over 2, now we want 2 divisions because now there's 2 times 2, which is 4, which is going to be the whole. All right, so how are you feeling about this so far? Let me stop there here. I'll leave this up here. Oh, here, this shouldn't really be there. That's a 1/2. Okay, I'm going to pause here for a second. How are you feeling about what we've been talking about? Pretty good? Okay, this is making sense. Oh, good. I'm so glad. Okay, so you want to eat a round candy. Yes, I don't doubt that at all. All right, so can we move on to page number 5? Let's do page number 5 because we have to finish up our fractions so I can give you a math challenge. All right, adding and subtracting fractions. There's a sample at the top. Okay, here's what I want you to notice. Look at the 3. Here's the 3, here's the 3. Oh, and there's another 3. You mean I don't add the ones on the bottom? Nope. Anytime you add or subtract fractions, the 3 comes along for the ride. Whatever's in the bottom, they have to be the same, they have to match, and you don't add them, they just come along for the ride. You see, it wouldn't make sense to add because look, if you added the divisions, you would be changing the divisions. Where's my page? If I added the bottom numbers, it's basically saying you're multiplying because you're changing the divisions. And that's not what we're doing here. We're simply saying, hey, I have a pizza. I ate 1/3 of a pizza. You ate 1/3 of a pizza. Together, we ate 2/3, right? So we're not changing how many slices there are in the box. Okay, it's different though for the top. The top tells you how many pieces got added, or if this is a subtraction sign, it got subtracted. Okay, so just make sure when you're adding fractions, the first thing is always to check the bottom. So let me give you a problem. 1 over 2 plus 2 over 2. Are the bottoms the same, yes or no? Yeah, denominators are the same. So bring it along for the ride. All right, now take a look at the top. The numerator is the top. 1 plus 2 is how much? 3. Is it okay for this to be bigger than that? The numerator to be bigger than denominator? Absolutely. Yeah, the math can handle it. All right, here's another one. 1 over 4 plus 2 over 4. Okay, they're the same on the bottom, right? The denominator's the same. So let's bring it along for the ride. 1 plus 2 is 3. Excellent. Good, good, good. Okay. All right, what if I do, let's do a tricky one. Yeah, let's do a tricky one. Is that tricky? No. All right, so what do we have? The bottoms are the same. We'll bring it along for the ride. 2 plus 4 is 6. That's it. You're adding fractions. Should we do a subtraction one just for fun? All right, let's take 6 sevens and do something with it. 6 over 7 minus 3 over 7. What do I get? 6 over 7 minus 3 over 7. Any ideas? Okay, well, the 7s are the same, so let's bring them along for the ride. 6 minus 3 is, no, it's not 4. 6 minus 3 is 3. I get 3 sevens. Okay. All right, so that's it for adding and subtracting. Do you think you can handle this? Yeah, when you look at the whole page, it may feel overwhelming, but if we just do it one step at a time, remember, you just check the bottoms and then bring it along, and then you do the top. Just add the top, and that's it. Yeah, but sometimes when you have a whole page full of problems, your brain might go, ah! Hang on a minute. Okay, so now let's take a look at page number 6. Page number 6, okay? And I'm gonna move the rest of this here so you can see it more clearly. Okay, adding and subtracting fractions. So this is where I think a lot of the confusion comes in with students. And honestly, when I teach mechanical engineering at Cal Poly, I can't, at the university, I teach engineering classes, I have in the past. A lot of the time when the students make errors in their calculations, it's because of this. So let's take a look at what this is. All right, so what do you do if it doesn't match? What do you do if it doesn't match? Okay, so say I've got a 1/2 and I've got a 1/4. Okay, so you write this down. Okay, you write that down. If it doesn't match, we can't just start adding things. We can't say 2 + 4 is 6. That doesn't make any sense. What we have to do is what's being done in this picture. We have to say, okay, we're going to scale this up just like we did on that earlier page by multiplying. And then we have to make the divisions the same. We have to make the divisions the same. Okay, so what does that look like? All right, so 2 and 4. So would it make sense here? Let's work on the half. If I have a half, I can multiply a half by a number. And the one number I can multiply it by that nobody cares about is 1. If I multiply 1/2 times 1, you and I, we don't really care. That equals a half. If it's a clever form of 1, we can get away with it because it's still 1 and nobody really cares. So what do we do? Remember how we multiply. You put your hand over the bottom. 1 times 2 is 2. And 2 times 2 is 4. We just scaled it up. Look, the bottoms are the same now. So instead of writing a half, this will now become 2/4 is the same as 1/2 because we multiplied it by 1. If we multiply it by another number, this won't be true. But because we multiply it by a clever form of 1, 2/2. Okay. I'm also going to say plus 1/2, or 1/4, sorry, plus 1/4. All right, the bottoms are now the same. Bring it along for the ride. What is 2 + 1? 2 + 1 is 3. And there's your answer. Okay, so let's do this for a more complicated value, a more complicated problem, okay? So let's say, for example, we have, can you write this one down with me? 1/3 plus 1/2. Okay, see before, yeah, 2 is kind of related to 4, right? 2 times 2 gives you 4, but what if they're not? What if they're not related? Okay, if I have something like this, the easiest way to do it is to multiply by each other. So let me show you. So the 1/3, okay, we find a number that's common to both of them. So what is 3 times 2? 3 times 2 is 6. Great. So my common number is going to be 6. What do I have to multiply the 3 by to get 6? I multiplied it by 2, right? So that's going to be, so you write the 2 on the bottom and then you write the same number on the top. And now you do multiplication. 1 times 2 is 2. 3 times 2 is 6. We just scaled this up. 1/3 is the same as 2/6, right? Because we had 1/3 before. 1/3 looked like this. Here's our big slice of pizza, okay? What flavors would you put on your pizza? So I like basil and I like tomato. What about you? Chocolate chips? Did I seriously see somebody write chocolate chips? I'm coming to your house for pizza. Okay, so wait, get back to here. So what did we do? 1/3 is 3 is possible, 1, 2, 3, and then 1 is how many we have, right? 3 is how many make a whole. This is 1/3. When we multiply by 2/2, we're basically saying each one, instead of being one piece, it's now going to be 2. So we're going to divide each piece like that. Do you see how now there's 6? 1, 2, 3, 4, 5, 6 possible. Okay, 6 make a whole, but now there's 2 shaded, even though I didn't color in anything else. That's what we're doing here. Okay, so the 1/2, let's scale that one up. What do I multiply 2 by to get to 6? 2 times something makes 6. That's right, 3. So I'm going to write the 3 here, but then also put on the top. That way it'll be, we're just multiplying by 1, so we're not changing the problem. Okay. Now 1 times 3 is 3. 2 times 3 is 6. So what did we do? So originally it was a half. That's what a half looks like, right? You have half, I have half, everybody's happy because it's fair, right? But now because you multiplied by 3/3, that 3 is saying instead of 1 division, now there's 3, so you have to divide it by 3. You see that? How we made it 3 parts there? And you got to do the same on the other side. Okay, so now the numbers of divisions are the same, right? So I have 6 and 6, so I'm going to rewrite this number. 2/6 plus 3/6. So you basically add these two pictures together, and we get the 6 comes along for the ride. 2 plus 3 is 5. Okay, and that's, so when we add those together, we get 5, 6. All right, I'm gonna pause there and check in with you. Does that work the same for negative numbers? Good question. Yes, exactly the same. Only if we were to take 3, 6 minus 2, 6, we would just have 1, 6. So you just would subtract the tops. Good question. All right, so I'm gonna pause here for a second. I'll leave that up so you can finish taking notes. And then I'm thinking it might be time for a little bit of an application piece. What do you think? How are we doing so far? It's easy when you draw pictures. Good. Butterscotch chips and Reese's on a pizza. Wow. Okay. All right, so for those of you who are saying, hang on, you're still going too fast, not a problem. Remember what I said at the beginning of class. I am recording this. You can go through this. You can play the recording back and have me say the things as much as you want. You can even slow down my talking speed in the replay, okay? So I have to keep going because we have some fun stuff we're going to do now. So actually, that was it for fractions. How are you feeling? I'm feeling pretty good? Okay, yay. If that was your first trip through fractions, I want you to stop and I just want you to watch this next piece. If this was a review and you feel comfortable, then you're going to turn to the map and we are going to work through a problem because I want to know from you, where do you live? If you live in the United States, if you don't, please tell me where you live as well. I only had the map for the US for this next part. Can you tell me what city you live in? What city? And if it's not a city that's going to be on a map, like just tell me the nearest big city to you. I'm going to pick 2 people right now and we are going to go on a road trip. We're going to go from one student to another student. Okay, so do that right now. Go ahead and submit right now. Tell me, where do you live if you live in the United States? If you live outside, again, you're welcome to put it in there. I'm only going to pick the ones that I have a map for. The world map was just too big and then we have to take into account curvature. You get the problem. All right, so we had to start somewhere. All right, so this is time for a practical application piece. So question, who likes a good road trip? Yep, me too. Where should we go? Let's go visit a friend. Okay, so I've given you enough time. Now we're getting all the submissions for people. All right, so, oh wow, I live in the USA. Can you be more specific? Oh, we have, okay, I'm going to say hi to the families outside of the U.S. while I give you about 15 more seconds to type it in. London, hello. We have Scotland with us, hello. And we have Auburn, not sure where that is. Victoria, BC, excellent. Singapore, hello. We have Germany. We have, people are just writing in countries, so oh, welcome. This is so exciting. So hello. I am so glad you guys are here. You're enjoying the class so far? Okay, good, me too. All right, so I have 2 students. Great, I'm going to pull Amanda from Washington, D.C. Oh, no, you were from Phoenix. Washington, and Zoe was from Washington, D.C. All right, so let's grab our map. So if you're new to fractions, just watch this part. This is practical application. If you're not, you are gonna go step by step and we are gonna plan a road trip. Let's do it. You guys ready? And you also get to tell me what kind of car we're going to drive. I don't know. What do you want? Do you want a Bugatti? Do you want to be in a Ferrari? Do you want a minivan? Like where? What kind of? Okay, we'll worry about the cars later. All right, right now you should have a map of the United States. Okay, so grab that. And now I want you to find the locations for Amanda and for Zoe. We have one person was in Phoenix, so put an X there. And Washington, D.C., if you're not familiar, it's right there. Okay, so go ahead and mark that out. Okay, we are going to take a road trip. We're going to go Phoenix, PHX, to Washington, D.C. That is where we're going. All right, we're going to plan a road trip in 5 minutes. Here we go. Okay, so you tell me, is this the way we're going to go? Get your ruler. Can I drive that route? Notice that I said drive, not fly. Can I drive that route? Yes or no? No, not without getting a whole bunch of people upset that you're on their land. Okay, what can I do? Okay, so watch this. You have a few options, and not all the roads are on here because the map is the size of your paper. I get that. Okay, so let's see. Maybe I'm going to go down here and maybe up to Albuquerque. You want to go to Oklahoma City? We could do that. Go to Oklahoma City, and maybe we'll go there. We'll go to Columbus, Ohio, and then we'll come over to Washington, D.C. Okay, you tell me, is the squiggle highlighted line longer or shorter than the straight as an arrow black line? Yeah, it's a little longer, isn't it? Okay. So knowing that, let's see, really quickly. There we go. The distance from Phoenix to Washington, D.C., I was doing this while you guys were typing it in. Phoenix to Washington, D.C., okay? It will take us 34 hours of driving, okay? And we will go a distance of 2,160 miles if we take the squiggle route, okay? So the highlighted route, okay? This distance here is about 1,900 miles. So it's a few hundred miles shorter depending on which roads we travel, right? Okay, so it's gonna be, this number is the one that's gonna be a little bit longer. Okay, so we have to make some assumptions. So first, who drives faster in your house, mom or dad? Okay, how fast do they go? Tell me how fast they drive. Well, this is important, right? Okay, so assume we don't want to get tickets. It looks like you guys are saying about 60 miles an hour. So I'm going to write that down, 60 miles an hour, okay? And then how long can you sit in a car? You tell me, how long are you comfortable sitting in a car if you're going to go see your best friend? It's somewhere you want to go, you're excited, that cooler is in the back, it's got your favorite sodas and your favorite snacks. You're on a road trip, you're going to stop every so often, right? How comfortable are you sitting in a car? 1 hour? Okay, well, that's going to take us forever to get there. Hang on. Okay, I'm reading some of your responses. Okay, I'm going to say most people are writing in about 6 to 8 hours. So I would say, let's do 6 hours because 8 is a long day. Okay, so we're going to assume we're going 60 miles an hour and we are driving 6 hours every day. So per day, 6 hours a day. How long till we get there? Okay, so question, if we're going 60 miles per hour, how many miles do we travel in 1 hour? In 1 hour? Yeah, if we go 60 miles an hour, so this is an hour, we went 60 miles, right? 60 miles per hour. What if we drive for 2 hours? Yeah, then we'll go 60 plus 60, so now this is 120. Okay, so this big thing here is 120 miles. What if we go for 3 hours? Okay, 60, 60, and 60. 6 times 3 is 180. You see what we're doing? So if we multiply how long we sit in the car for by our speed, we're going to get how far we travel that day. So if we go 60 miles every hour, and we sit in the car for 6 hours, how long can we travel in a day? What is 6 times 6? Don't worry about the 0. 6 times 6 is 36. And now put the 0 on the end. We will have gone 360 miles. Okay? The hours and hours, they cancel because it's top and bottom. Remember when we did 3 over 3, 4 over 4? It works with words too, hour over hour. Okay? So we went 360 miles each day. Okay, great. So the question is, all right, so 360 miles. Look how far we have to go though. All right. So somebody's asking about this number. Actually, just put a line for this number right now. This is the number I'm interested in. Okay, this is Google telling me. And, you know, honestly, I actually want to do this just based on miles because that's what we can get from a real map. All right, so how long is it going to take us to go 2,160 miles? Well, I don't know. That's why we have fractions. Okay, so let's figure this out. So if the first day I go, here, that's an X, 360 miles. That's day 1. Here's day 2, 360 miles. How long have I gone in 2 days? 360 plus 360, right? What if I do 3 days? Then we add another 360, right? 360, 360. So we keep adding. So does it make sense that I could say, okay, we're doing 360 miles in a day. Okay. That's how many miles per day, but I don't know how many days that's going to be. How far do I have to travel? Well, I'm traveling 2,160 miles. So write that number on top and draw a line between the two. So here's the total amount that I need. Okay, this is like having, say for example, you made this many cookies. Okay, And every person gets this much. And so you want to know, well, how far does it stretch? So you're going to be adding up all of this amount. Okay, so how do we do that? So we have the total amount of like cookies that you made divided by how much everybody gets. So the total amount of the trip's going to be divided by how far you're going to go in a day. So grab your calculator, if you have one. If not, you just borrow mine. 2,160, okay, divided by 360. I have, oh, that's a perfect number, 6. So what does that mean? 6 days will get me from Phoenix to Washington. This is the last part. Watch this. So 360 miles is 1/6 of the trip because it takes 6 days. Every day I go 1/6, 1/6. Well, here, I'll just write it right on here. Right, so here's the halfway mark. This is 1/6. This is 360 miles. 360, 360, 360, 360, 360. Okay, imagine they're all evenly spaced, like this one's a little far. Okay, so this is 1/6 of the trip, right? So this mark here is 1/6. This is 2/6. This is 3/6. This is 4/6. This is 5/6. And guess what? 6 over 6 makes a whole trip. Yay! We did it. We got from Phoenix to DC. Now, the cool part about now you don't want to use, somebody's asking about using a Sharpie on a real map. No, don't do that. This is a printout. Okay, and so the cool part about this is now you can look and say, okay, this is my range for the day. Where's a good place to stop? Okay, this is about where I'll be. Where's a good place to stop? And you can start to take a look and plan some things that you could do, right? Does this thing with a 6 remind you of anything? What if I give you a hint? This is what a ruler is based on, fractions. So especially the inches here, inches are based on fractions. 1/2, 1/4, 1/8. This is how and each inch is a whole. This is fractions. All right, so yay! How are we doing there? You guys ready for a challenge? Yay! All right, if you like that, put a big old smile on your face because we are done with fractions. We did fractions in 35 minutes. How was that? People are writing and my brain is about to explode. Yay! Okay, so here's what I want you to do. Challenge time. Do you have a piece of yarn or a piece of string that is about your wingspan? Wingspan, you put your arms out like that. It's about that long-ish, maybe a little shorter-ish. Okay, about that long. Have you got it? You're going to need 2 people for this. 2 people. If you only have 1 person, I'm going to show you how you can do that right now. The first thing I want you to do is take the end. You're going to do this to both ends. Okay, let me undo it. Okay, take the end. Yeah, this is we're still in math class. Okay, so the end kind of looks like this, right? Take the end and go like this. Okay, so it looks like this. Okay, hold it here. Now watch me before you do it because I'll do this twice. Okay, I'll do it once in front of you and then I'm going to do it again. Hold it here. And then make a circle and tuck it through. Okay, I'll do it again, don't worry. Okay, make it large enough so you can put your hand through it. You got it? We're making some handcuffs. So let me do it again, Okay, so you're gonna take this end just like this. Okay, kind of make a U, right, just like that. Make it long enough so you can get your hand through and there's extra to make the knot. Okay, hold it here, go around your fingers, and then tuck it through. Okay, and then you can, if you leave it loose, you can kind of like adjust where the knot winds up so it's not way up here. Okay, and if you need help, ask your grown-up that's nearby to help you with this. Okay, so we are looking to make one of these on each end. When you're ready, you can put them on. All right, so basically we're gonna tie you up in knots. Okay, so this challenge, there's 2 challenges today. The one for fractions is called jailbreak, okay? It's called jailbreak, and I'm gonna show you how we are going to do this. Give me just a second. I am not sure why it's not starting. Give me a second. There it is. Okay, so I'm going to share a video with you. This video is like 2 minutes long. It's super short, but it'll show you how I want you to interconnect. And again, if you don't have a partner to do this with, that's okay. Everybody's going to have this. They're going to have their handcuffs on. And then you're going to loop them in a special way, which I'll show you on the video. And then your job is to get free without taking it off. Okay, it's to get free without, so now like, you can keep your hands nice and big so they won't come out. Your job is to figure out how to get free. Okay, you're gonna keep these on. You should have these on when you're done, but you're gonna get free of the person or the teddy bear or the chair that you're using as person number 2. Okay, you ready? You wanna see what it looks like? Okay, So here we go. Let me start up the video. Okay. All right, so I'm going to share this with you, and I'm going to talk through it. Okay, do you see how I put bracelets on the end of mine so you could see it much more clearly? All right, so you want one for each person, and what you're going to do is you're just going to have a long loop with these little links at the end, these hooks at the end, right? These loops, and I'm going to put my hand through them, okay? All right, so, yep, you just want it to sit there. You just want it to sit there, and then, okay, then what we're going to do is since I don't have I'm showing you how to actually put it around your arm here. Since I don't have a buddy, I'm gonna use my stuffed animal. You see it? Okay, so he's gonna have his handcuffs, and that's okay. You can totally do this with a stuffed animal. And do you see how he's handcuffed, right? One long loop from one arm to the next. Okay, so go get a stuffed animal, go get a friend, whoever you're doing this with. You can do it with a chair. The legs of a chair will work as well, okay? All right. Now I want you to watch the second part. I'll play the second part twice because it's really important how you put it on. Okay, watch this. Do you see how I'm going up and around his? So now I'm connected. Do you see how I'm connected? And then I put the handcuffs on. Okay, so let me play that part again. Okay, so he's looped. He is completely looped from, let's see, I don't know if you can see my pointer here. No, my pointer isn't showing. Wait. Let me see if I can get it to show. Sometimes I just need to uncheck it and check it again. Okay, do you see yeah, you see it now? Okay, great. All right, do you see how it's one big loop? Okay, so handcuff here, looped, handcuff there. Okay, nothing fancy. Now watch this. Take one of them and go under like this. And now put the handcuffs on you. Okay, you got it? You want to play it one more time? Okay, so go under. So just basically connect them so you're connected together, right? So you just can't run apart from each other. Okay, so you each have a handcuff on. The question is, how can you get free without taking the handcuffs off? Okay, remember he's got his loop, you got yours, you're connected, one is interlinked with the other. The question is, how do you get free? Okay, and so there's me hitting the pause button because I'm not going to tell you what the answer is yet. All right, so that is your challenge. Go ahead and stand up, do that now. I'm going to give you... We're going to take a quick break before we roll into decimals. Okay, so I'm going to give you about 10, 12 minutes. I want to answer all the parent questions about the online math program that I have. I'm going to do that now while you kids are engaged. You ready? Okay, on your marks, get set, go, 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 go. When you hear me say ding, 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 that's when you're going to come back. Okay, that's when you're going to come back. All right, parents, how is it going? So basically, we did a math lesson and I tied up your children. Okay, so you can leave them like that, I guess. All right, so excuse me. I've gotten a lot of questions from parents about the math lesson that we did. Let me take some time to answer those questions right now. Basically the question is, tell me more about your math program. I'm going to do that now. And then when I come back in about 10, when the kids are done in about 10, 12 minutes, we are going to do, we're going to start our lesson in decimals. So this is a good stretch break. So students stand up, stretch. Well, you should be handcuffed. Get a sip of water. Parents, go ahead and just grab a cup of coffee and come on closer. I want to make sure you and I'm actually going to tell you a story. I'm going to make sure I have all of your questions answered for what we've been doing. Okay, somebody was asking, how do you teach like this when we don't have Aurora in front of us? Yes. Okay, so let me tell you a quick story while the kids are working. All right, so back in, I want to say November 2016, I was asked to take over teaching a combination class. It was grades 4, 5, and 6, and it was math. The regular teacher had unexpectedly left the school right in the middle of the term, like didn't show up to work the next day. So the principal and I were friends, and so she had called me up, and I had arranged to go ahead and teach that class while she was in the process of hiring somebody new. So the class was this really challenging mix of kids who were interested but really confused by math, and others who were way behind, totally disengaged. This teacher basically did nothing but just sit in the back of the room and work with one student at a time. So the class was absolute complete chaos. So I knew something had to be done and fast. And so rather than teaching the traditional math approach that I would do, I actually decided to do the exact opposite. And within just 3 weeks, the class was back on track. Now, this was a class that was off track for over 18 months. This had been going on. I know, it just blows my mind how bad this class had gotten. Kids who had been struggling before were excited, and now they were raising their hands while I was in their classroom. And the ones who had lost like their self-confidence or even just hated math became some of my top students in just 3 weeks. And a few even wound up liking math so much they were actually doing it for fun outside of class, and they were asking for book recommendations because they liked it so much. I'm not kidding. So the school principal, as well as other teachers in that school, were in total disbelief as to how the class that they thought was a total disaster, and by the way, one that nobody wanted to teach, was now one of the top performing groups of kids in the entire school. So the funny thing is that this was actually easier to do than anyone imagined. In a moment, I'm just going to share with you that thing that allowed me, what I did in the classroom that allowed me to turn this class around in less than a month. It's really simple, single thing to do. It really makes a real difference in learning, and it lets kids learn faster, understand better, and actually enjoy the process. And this is the method that I actually was using in our class today, but I kind of snuck it in, so you may have not seen it. So let me just tell you really quickly what it is. The secret, the big secret, is basically the method that I used is the same method you're going to use with your kids today. I'm going to do it again when we talk about decimals in just a few minutes. So before we introduce any real solid academics, we have to show them what the concept is and what it actually means in the real world, and then have them relate that back to the concept itself. So you can't just teach concept, and go through drill worksheet. That's not what we did in our class today. What did we do? We introduced a concept. We had some meaning around it. That was the pictures with fractions, what they meant, and the ideas about candy bars and pizza pies and all that kind of stuff. And then we did a practical application, which was the road trip. So we related a real world situation that used that concept to solve it, but we did it all within 30 minutes. See, kids are always asking, even if it's just in their heads, what am I ever going to use this for, and why should I even care? And kids, if you can hear me right now and you agree with this, give me a head nod so your parents can see it. Yeah, what am I ever going to use this stuff for? So they have to have a solid answer, and when they do, they're going to work really hard because they're already curious, they're already interested in what it is that you want to share with them and want them to know. And they understand it way better. I mean, they're going to get bored or disinterested if you don't give this to them. I mean, as human beings, this is the way we're wired. I mean, don't you learn something much better and faster if you really understand the bigger picture? Yeah, it works with math concepts too. So when I started my online science program in September, when kids first my science, I've been having that for a while, my online math program back in September, and I had my first group of students coming to me, I had asked them before we started, where are you in math? And a lot of them had reported back saying, you know, my kid's struggling, they're behind in math, they're really struggling to learn the concepts, I know they could be doing better, they're just not. Some parents wrote in and said, my kids are stressed, or they have no self-control, self-confidence when it comes to math. They know the answer, but they won't say it because math is such a challenge, and they'll like lock up and freeze. So others had also written in and said, you know, my kids are really excited and they want more, but I don't know how to support this. So we had people from all over the board. So we started teaching my math program back in September, and within a few weeks, using this real-world practical application situations for learning math, most of the kids had drastically improved their grasp in math topics that used to be hard, and they actually were looking forward to doing math. Parents actually wrote in and literally said, I see a child loving math who a few weeks ago wanted nothing to do with it. And the parents who were most surprised were the ones where the kid would wake up and say, oh, Mom, can we start with math today? And the parent's jaw was on the floor, and they would write in and call us and tell us, and like, I never thought I would, like, I don't know what you did, but there is something different about this. And the kids that were enjoying and already loving math, now they can enjoy it on a whole new level because of the practical application pieces and the labs and so forth. So I get parents and I get emails from parents in my new math program telling me about how they're feeling. Like, parents don't hesitate to tell me that. They'll say, I am so relieved that now my kid is back on track with math and doing really well, and that they don't have to worry about this area with their kids anymore. So if you've been with me so far, I'm guessing you really care about your child and seeing this kind of approach and seeing how it works for them, how this might work well for them with learning math. And you probably also wish you want them to do math so you don't have to struggle. Does it sometimes feel like it's pushing a freight train up a hill, like, oh, do your math. No, I don't want to. We have to. And you're like, oh, fine, right? And then it's like drag. So, or maybe it's the other way. You know, your kid loves math and you want to support it, but they are way above and beyond where you just don't know how to support this level of curiosity and interest, and you want to make sure that they're constantly challenged, because if they're not, they're going to turn off and focus on something else. So if you can relate to any of these things, I think you're going to be interested in this. I've actually created, here, let me show it to you. I've actually created a hands-on learning program. It's a complete brand new math curriculum. It's called Supercharged Math. It's going to help your child do better in math, learn math more easily, and actually enjoy the process of learning. It's for grades 4th, 5th, 6th, 7th, and 8th, and uses this approach that I just mentioned and I just described to you. And so if your kids are struggling with math or falling behind or stressed or frustrated or bored and you know they could be doing better, or maybe they love math and science so much and you want them to thrive, this is a program that could really work well for you. Now, if you can't relate to any of these things, well, maybe this isn't the program. But if you can relate to these things, this is a program that can work really well for you. In fact, I guarantee that your kids are going to succeed in the program. Let me tell you a little bit more about it and how it works. So when you enroll in my Supercharged Math program, here is what you'll get. You get a complete self-guiding homeschool math curriculum program. It's in 2 different tracks. There's grades 4 through 6, and there's also grades 7 and 8, depending on your kids' level. Now, kids can go through it on their own, so you don't need to do it with them, or you don't even have to know much math yourself because I do all of that for you. There are video-based lessons taught by me, a real teacher, and they are recorded also so you can access them on your own schedule and do the program at your own pace. If you need more time with something, then you take it. If you already understand this stuff, skip to the next one. Each lesson is prepared by me personally and taught like a regular teacher would with a group of kids. And every single one of these lessons will help your kids relate what it is we're doing to the real world. So you're not going to find any silly cartoons or ridiculous video games that are pretending to be educational. That is not what this program contains. You're also going to get live Zoom classes each and every week to explain the concepts live and answer your kids' questions directly. The program is based on real-world math, and it exceeds all Common Core standards for those grades 4th all the way up through 8th. The program includes workbooks, handouts, exercises, worksheets, quizzes, tests, evaluations, and so much more, including a place to ask questions and get back real answers. I'm also going to include 100% money-back guarantee, no hassle. You try it, doesn't work, no problem, full refund guarantee. I'll tell you about that one as well. Okay, so for example, for fractions, instead of just learning to use fractions by going through page after page of boring worksheets, drill worksheets over and over until their eyes glaze over, kids are going to use fractions to run a bakery business, figuring out how much stuff they're going to need when they calculate their prices of profits for the things that they're making, the baked goods and the lemonade and all that kind of thing. They actually get to run their own business while they're learning the math concepts. We're going to learn about units and decimals by graphing and figuring out how high and how fast rockets go, depending on how much that rocket weighs, how much fuel it's got on board, just like a real NASA engineer would. And we're going to learn about liquid measures, percentages, by being a chemist in a lab and calculating just the right concentrations that we're going to need to make our chemical reaction work just the right way so we get the right stuff out the other end. And we'll discover things about measurements and angles and geometry. We're going to have geography lessons as well. We're going to track in real time some dolphins and sea turtles while we study geography because that's related to geometry. We're also going to learn how an architect and construction contractor use geometrical things to build a house, for example. There's hundreds and hundreds of real-world math applications. So like I said, this is totally different than anything else out there, and honestly, I think it works way better. So here is how my Supercharged Math program will help you and your kids do great at math. The program includes video-based lessons where I teach the concept in a practical way that kids can relate to the real world, just like we did in class. And each of one of these classes is recorded, so you can go through it on your own pace, and so you can do this program at your own schedule. So there are also live weekly tutoring sessions over Zoom where your child can get help with questions they have or problems that are challenging for them, and they can actually work with other students as well as the teacher in a small group private tutoring session environment. And in addition, you'll also get workbooks and worksheets and handouts so your kids can practice what they just learned in a way that's fun and totally interesting. So we're also going to apply each one of the standard math topics to real-world situations, so it's fun and interesting. So your kids will not only learn how to do traditional math problems much more easily and word problems much more easily, but more importantly, they're going to learn why they need to know it and how to apply it to the real world. So here's some of the topics that your kids are going to get to learn about. Fractions. We're going to add, subtract, multiply, and divide fractions and mixed numbers. and really learn what those things mean. Really very simple. We did about half of that today. And decimals, we'll learn how to work with decimals and see how they're everywhere around us. We're going to do that in just a few minutes when your kids come back. Percentages, you're going to discover how powerful percentages are, especially when it comes to, drum roll, business math concepts. We are going to spend 7 weeks learning about personal finances and business math concepts. This is stuff that adults wish they would have gotten classes in when they were younger. So we are including that as well. You're going to learn about graphs and charts and how business people do their analysis for their businesses, and also how to track and make sure you got enough money at the end of the month to not only pay for your bills, but to have some fun and do some fun experiences for yourself as well. Algebra concepts. We're going to dive deep into the engineering world and science world and learn how to apply everything from variables, constants, expressions, equations, polynomials, quadratic equations, all to real life. We actually calculate things like the forces a black hole has and other things that are rotating around a black hole, what they experience. We're actually going to learn how time actually changes rate when you have a huge gravitational pull on it. We're going to learn how to estimate the expansion of a star that's exploded, so looking at the shock waves that we've taken photographs of and be able to tell some stuff, basically do science from photographs that we had taken. We're going to discover brand new planets that are outside our solar system using math. And we are going to determine what their orbits are and what their mass has to be. We're going to explore the power of a star just by taking a look at some data from incoming light from that star, and so much more. So this is all based on real scientific data. And for geometry, good question. Okay, so geometry, we're going to take, for example, the point, the line, the plane, and shapes and figures, and we're going to learn how to, for example, plan a launch window to Mars, because landing on Mars is hard. It's small, it moves, right? And we're on something that moves and rotates too. We're going to take a look at how we estimate the size of Saturn's new rings that were recently discovered. We're going to chart the comet tails that we've actually been discovering new comets because our instruments have been getting better. So there's all these new comets nobody's ever seen or heard about before. We're going to be able to tell you what the orbits are just based on some photographs. You're going to take a look at how to design telescopes, figure out how much water is on the moon, and so much more just from scientific data. So kids are going to learn both. Somebody's asking about the metric or the standard. They're actually going to learn both because that's how the world is right now. We want you to be fluent in both systems. So you're going to be doing both standard English and the metric system. So your kids are going to enjoy engineering math applications all year long. We're going to focus on the math concepts that we just learned right away, and then we roll it right into an application in that same session. So here's some ways I think that my Supercharged math program will really help you and your child. It will help kids who are struggling with math to catch up and improve their grades. It's going to help kids work through real-world situations and examples that they are interested in so they can learn it much more easily and actually enjoy it. It's going to help your child regain confidence in math. And as a parent, you can relax knowing that your child is back on track with math and you don't have to worry about this area in their studies anymore. And your kids, they won't be stressed when it comes time for them to do math because it's going to be fun, it's going to be a happy and a positive experience. And as a parent, you're not going to be stressed worrying about how your child is doing when it comes to math. And also the parents that are asking about tutors and high-priced programs. Yes, so this program includes it all, so that you don't have to pay for expensive tutors, no high-priced after-school programs or after co-op things. Everything is all included, including the workbooks. So if you want your child to truly thrive in math, learn it better than you ever imagined, and really enjoy the process, then you'll want to enroll in my Supercharged math program today and get a big discount on the price just for being in class with me today. So right now, I'm going to give you the chance to enroll in my math program, and for over 75% off. The regular price is $350 for the program. That's how much it would cost if you were just to go to my website and buy it. But today, I'm going to give you a huge discount on it. Today's price for the program is $87 for a full year, or 6 monthly payments of just $16. So the program comes in 2 levels. You pick. You want grades 4 through 6, or you want grades 7 and 8 together. So when you enroll, you can choose whichever level is right for you and your kids. And if the 75% discount isn't enough, I'm also going to give you 6 free bonuses when you enroll today. Plus, you're going to get a risk-free money-back guarantee as well. So here's what you get when you enroll today. You'll get a full enrollment to grades 4 through 6 or 7 through 8. And if you want to get both of them, I see questions about that. We do offer a discount if you want to get both of them, but they're both separate programs. And then the first bonus I have for you is we are going to include with your enrollment today the live Zoom classes with me, and I'm teaching every single week. So I'm going to teach a live class for grades 4 through 6. I'm also going to teach a live class for grades 7th and 8th. And so this bonus is worth $597. The second one is it's only one enrollment per household. So if you have a student in grades 4th and a student in grade 5th, then just sign up for one. And then I will give you access to all the students in your house can access it just for the price of one. Okay? Now, if you would like bonus number 3, if your students are struggling with their multiplication tables, then you'll be interested in this bonus. This one's worth $20. We're going to spend literally maybe 30 minutes, and that multiplication table will be handled with this video. So I'm going to include this as an extra bonus just because so many students have mentioned, like, my kid's struggling with multiplication, it's really holding them back. It won't after you watch this video. The fourth bonus that I have for you is how to memorize almost anything using a very secret, well, not too secret, very special 100-year-old secret phonetic code. And this bonus is worth $20, and it's really easy to use. And it's how mathematicians can remember numbers, really big numbers, just by converting them into something they can remember much more easily. And so I explain exactly how to do that in that bonus. Bonus number 5, also more math tips and tricks to make learning fun and easy. This is an extra bonus. There's about 50 videos in this bonus alone. So this one's worth $25. These are additional tips. The videos are 3 to 5 minutes long, and they're all organized so you can go through them and see which ones are most interesting for you and your kids. And a lot of these are on mental math. So if that area of math is interesting to you, you definitely want to take advantage of this one. And bonus number 6, how to add and multiply quickly in your head, worth $25. Again, this is another part of the mental math series. We're going to add that into what you are enrolling in for today. And so if you enroll today, I will actually extend your enrollment. So your enrollment will begin today, and I will add however much time I need to add to get you to June 1st of 2024. So you can start using it today, and it'll cover all the way through next year. So the total value for these things, so everything on the slide that you see now, for the program and all the bonuses is over $1,300. And it's even a bigger savings because if remember the one enrollment per household. So if you have 3 kids, you're only still paying for one. So you're going to be saving even more if you have more than one child. So your specially discounted price to enroll in my Supercharged math curriculum for a full year plus whatever else other time you need, so it ends in June of 2024. You'll get all these bonuses. It's just $87 today. You can split it into 6 monthly payments of just $16. So that's a savings of over $1,300. So if you split that up and divide by how much time that is, kind of like we did with the road trip, it's about 25 cents a day. Like, you can't even get a gumball for that anymore. So in just a few weeks, imagine your child can be doing so much better in math than they ever have before. They're more confident. They're enjoying it in a totally new and different way. I mean, what would that truly be worth? So if you're interested in my program, you want to click to enroll to get your kids this gift of math learning for the next year. So you can click the button to get started and take a deep breath going, I've got this totally handled. Oh, somebody's asking about the money back guarantee. Yes, glad you asked. So you parents who've tried other programs, specifically, I wanted to talk to the parents who've tried things like expensive tutors and bonus sessions after school or co-op sessions with specialty teachers, or maybe even talking to teachers and anything else that none of these things like worked. I know how you feel. I want you to know I've got you covered. So even though most kids will get great results within the first couple of weeks of using my program, if for any reason you are not totally happy with my Supercharged math program, all you have to do is let me know within the first 30 days and I will give you a full and complete refund. There's nothing to send back, there's no hassle, there's no fine print, and we're still friends. So I want you to try it, really take it for a good test drive, and if you find, it's not for me, that's okay. Within the first 30 days of when you enroll, so when you enroll today, it will be now until 30 days from now, try out the program. Take as many of the classes as you can, write in, get all your questions answered by me. Make sure that it's really going to work for your child. It's honestly the best way, because people say, will it work for me? Will it work for me? I don't know. So the best way to know if you're going to like that flavor of ice cream is to give you a sample. And this is how we're going to do it. So try the program. If you don't like it, no problem. You shouldn't have to pay for it, but you do have to let me know within the first 30 days. Now, this can really change your child's world by giving them this gift of learning math the way it was intended. Math is the language of science, and that's how we teach it in my math program. Okay, so we're getting a lot of questions here. Yes, I agree. Here, I have a slide for that. So somebody's saying, what is your background? That is an excellent question. Okay, in case we just met, my guess is you want to know a bit more about my background. I mean, for me, if my kids were going to spend a lot of hours learning from anybody else, whether it's an author of a curriculum or a curriculum writer, right? Or the teacher in the front of the classroom or coach, right? I would want to know more about them, wouldn't you? That just makes sense. So here's a bit about me. I'm a mechanical engineer. I taught math and engineering at Cal Poly State University, which is the number two university for mechanical engineering in the United States. I did PhD work at Stanford University. I worked for NASA starting when I was 17, and I was president of the Central Coast Astronomical Society. I became a licensed pilot when I was 19, and for the past 20 plus years, I've devoted myself to teaching math and science to kids in grades K all the way up to 12. And it started because when I was teaching at the university, I was so surprised how many students were bored and turned off and frustrated by math, and I decided to do something about it. And that was 25 years ago. And so what you are seeing is the result of all of that work of me trying lots of different things with lots of different students, teaching at the university, and now knowing what your kid needs to know and understand before they hit those college classes. That's what the program is based on. So here is, somebody's wondering, yes, we do have so if you have specific questions about how to pay for the program, like PayPal or if we're a vendor for a school, that's fine. Send me an email, aurora@superchargedscience.com, aurora@superchargedscience.com, or drop it in the comments and we will see it. Just make sure your email's there so we can have a way to respond back to you. And whatever your special situation is, I will make sure that me or my two assistants, which are Tanya and Crystal, one of the three of us will be in touch with you. Okay, good. All right, so let's go. So kids, how are you doing? Did anybody get free? Okay. So, I mean, yeah, so remember, so somebody's asking, you put the slide up, there it is. Remember, if you're enrolling today, welcome to our science family. It's a full year enrollment from now all the way through June of 2024, and you want to pick which grade level you would like for your child. So it's grades 4 through 6, which covers percent, fraction, and decimals. Grades 7 and 8 covers algebra and geometry, okay? And if you want both, we do give you a discount when you purchase both, but they are separate programs. They have separate Zoom calls, Zoom information. If you're not on Zoom, that question, so we do have a private live stream on the website. You can participate that way as well. So you don't have to be on Zoom. You can just watch it live, just like you're watching me live right now. Okay. And so if you have any other questions that didn't get answered, we're going to continue with class right now because I think we've had plenty of break. Yes. So if you have more questions, drop it in the chat or go ahead and send me an email, aurora@superchargedscience.com. No one else can see what you are writing. Only I can see your comments, as you've probably figured out by now. So this is not a free-for-all chat where people can see things. So anything you put in the comments is private. So we do get those. Okay, good. So yeah, you can click the big button. Where's the button? So if I am full screen, hit escape, you want to be able to see a button below this video. And yes, today's price is 75% off. That's correct. So you can click the big button to enroll today. What happens when you when you click that button, it'll open a page, and then you pick which level you are interested in. And it does include a 30-day money-back guarantee. So you can try it. If your kid lights up when it's time to do math, you know it's working. So then that's fantastic. And then I'm guessing you got everything you hoped for and even more out of the program. So yeah, I believe that your kids have the ability to do way better than they currently are in math, especially if they're struggling, especially if they're challenged. And this is my way of helping you do that. Or if their kids are already doing fine and they want to do even more, then we can take that passion and understanding to a totally new level. And they're going to be taught in just the right way that will prepare them for college. As I mentioned, as a mechanical engineering instructor, I know what it is your kids need to learn and understand, and I've seen what happens when they don't and how much they struggle because this didn't get handled upstream, which is where we are right now, which is why I'm here right now. Okay, so how are we doing? All right, kids, ding, 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 come back, come back, come back, ding, ding, ding. All right, so how did you do? You're stuck and you can't get out, okay? I promise, I will give you the solution to this. But first, what I want you to do is take the handcuffs, just slide them off your hands. So if you're on, go ahead and just take a break. Sometimes it can help, especially with a challenging math problem. Happens all the time. To me too, in math. It can help to do something else because this you understand and know because you've been working with it, and now it's going to go to the back burner of your brain. your front part of your brain is going to think about something else, and then you might have an aha that goes, oh, wait, I'll say something like, all right, 3.2 minus 1.5, and you'll be like, oh, I got it, and it won't be what I'm talking about. It'll be this other thing that you're processing. So we actually like it that kids work on multiple things at once. All right, so go ahead and slide your hand out of the handcuffs, put them aside. We will come back to this. I promise you will get the solution. All right, and if you did get loose, congratulations. This is not an easy one. All right, and I do have another challenge for you. So that was more geometry than fractions. Yes, I agree. All right, grab a sip of water, take a bite of something, and how about we continue? Now, if your student is full, if this is like way too much, remember, I'm gonna teach the class so I have it for the replay. And then I'm gonna put the replay on a bonus page, and then you can have access to all of it. Okay, so step-by-step instructions to everything we're doing for fractions, decimal, and percent. You go through it at your own pace on your own time. Okay, put a big old smile on your face, rev up your engines, because here we go. We are gonna let's talk about some fractions. Okay, I know you guys are asking me a lot of really good questions. I'm not getting to all of them. So currently there are 987 questions right now in the queue. So yes, okay, so keep asking your questions. I'm gonna do my best to pick and choose the ones that I think are serving the students the best to answer right now. And let's go back down to my desk and let's tackle some decimals. Would you agree? Would you agree? Okay, so let's go ahead and put our map aside. Put your map aside, okay? And then I'm gonna put my calculations aside, okay? And then the next page that we are gonna tackle together is page number 8. All right, so you're on page 8. All right, so here we go. Okay, so for page 8, we are going to talk about something called decimals. Okay, so decimals, we're all familiar with decimals mostly because we live in a society that uses money. And so decimals are basically a whole number part, like the 32, and we call this a fraction. So write in the word fraction right there. So it's in your handwriting. So we have a whole number and a fraction. Sometimes the whole number is 0, right? So, or the number we have here is 0, okay? So that would be a 0, and that's okay. That's still a decimal. Okay. So let's take a look at a couple of examples. So I am going to write right here, I'm going to write 4.51. Can you write that down? 4.51. All right, so what do I want you to do with that? I want you to write an arrow, and then write the word 10, T-E-N, and then put a T-H after it. Okay, that's a tenth. Okay, and then for this one, the 1, I want you to write the word 100. And if you don't know how to spell 100, just look up here, 100, and then put a T-H after it. Okay, so what did we just do? So I would say this is, if the number was, here, I'm going to put my hand over the 100 for a second. If the number was 4.5, you can read the number as 4.5, or you can say 4, and then when the decimal point, you say the word and, so 4 and then you say the number, 4 and 5 tenths is how you pronounce this, 4 and 5 tenths. If there's another number after it, like this, 4.51, we say 4 and 51, so you say the whole thing, 51 hundredths. So 4 and 51 hundredths. Okay, how do we say this one up here? So this one, you can write it up here, write the word thousand, T-H-O-U-S-A-N-D, and then put a T-H after it, thousandth hundredths. Here, you can make it plural. So this is 32. The decimal point is the word and. Okay, I'll put and, A-N-D. Okay, 32 and then you just say the whole number, 945 thousandths. Okay, so that's how we pronounce these things. Okay, so how do we start to think about these? All right, so look down here. Can you say this for me? 2 and, there's only one of them, so it's going to be this word. 2 and 2 tenths. Okay, can you color it in? I have chocolate bars here. All right, I'd like to give you some because I know you like chocolate bars. All right, so how much is 2 and 2 tenths? All right. Well, if the whole number is 2, that means you ate this chocolate bar, whoops, and you also ate this chocolate bar. So you can fill in the whole thing. Yum and yum, right? Okay. All right, so that's the 2 part. That's the whole number. What about the tenths? Okay, so 2 tenths. So 2 and 2 tenths. 2 tenths, so 0.2 is 2 tenths. So 0.2 is 2 tenths, right? 2 tenths. If I just say it out loud, 2 tenths, and write that, 2 tenths. Do you see where the fraction popped out? 2 tenths is 2 divided by 10. If I take a calculator and I say 2 divided by 10, I get 0.2. So this is 2 tenths. That's why we want to know how to say these things. So this is 4 and 51 hundredths. So we would write the 51 hundredths as 51. Here, I'll write it over here. 51 hundredths. Do you see that? So whatever the word is, that's what goes in the bottom. Okay, so now let's see. 2 and, so there's a 2, and 2 tenths. So do you see how this chocolate bar has 10, it's been divided into 10 parts? You see that? All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you ate 2 tenths. So 10 is how many is possible, right? How many make a whole? So the whole thing is 10, but you only ate 2. Okay, so that's how much you ate. So 2 and 2 tenths. You didn't eat the whole one of the third one. If we did, then that 2 would turn into a 3. But you didn't. You just said 1, 2, and 2 out of 10 of the third one. Okay, give me a little smile if that kind of makes sense. Okay, 5 and, what would you say here? 1 tenth. Same thing, 1 tenth. All right, so let's color in how many chocolate bars you ate now. Yeah, so maybe Monday you ate 2 and 2 tenths. Tuesday you had 5 and 1 tenth. Yeah, you were really pigging out that day. Maybe you had a lot to do, right? You had a lot of things going on. You needed a lot of energy, so you increased your calories. Okay. Do you see how I shade, or I didn't shade them in. You see how I outlined, and now I'm shading in 5 candy bars, because you had 5 and, decimal point is and, 1 tenth. So out of all of these squares, you only ate 1 square. You got really full. Okay, so even though there's 10 possible squares, this is 5 and 1 tenth. So this is 5 and 1 tenth. It's the same thing. This is 2 and 1 tenth. Oh, I'm sorry, that's 2 tenths. 2 tenths. That's a 2. Okay, say this one for me. 3 and 4 tenths. 3 and 4 tenths. Okay, so let's shade it in. So let's shade in 3 whole ones. So Wednesday, you ate 3 candy bars and a little bit more. Not quite 4, but more than 3. Okay, so there's the 3. 1, 2, 3. And then you had 1, 2, 3, 4 of the little boxes out of the 4th one. So you didn't finish the 4th candy bar. So this is 3, 1, 2, 3, and 4 out of 10. All right, if this is making sense, give me a little smile. There we go. Okay, good. All right, so the next page is taking this one step further, because it looks like this. Okay, so for this one, it says here 3 tenths of the shape are shaded, right? Because there's 10 possible, 10 makes a whole unit, and 3 of them are indicated. So that's 3 over 10. In this shape, all 10 are shaded, right? So this is 10 over 10. This is a whole, just like we had in fractions, 10 over 10. Okay, so let's see how many wholes, tenths, and let's write the decimal number. So how many holes do you have? So like in this one, there's 4 holes, 1, 2, 3, 4. Not a hole like a hole in the ground, but a WH hole, like the whole thing. I can't believe I ate the whole thing, that thing. Okay, so there's 2 holes. How about in this one? Yeah, there's only 1 here. Okay, how about this one? 1, 2, keep counting, 3, 4. So there's a 4 there, okay? How many holes in this one? Yeah, 1, right? Okay, so we did that. Now let's take a look at the ones that are parts of a whole. So this one has 10 possibilities. So 10 make a whole, but I've only eaten 1. So the 1 goes there. So this one has 10 possible, but I've only eaten, how many is that? That's right, 5. So this becomes 2.5, because we just put the decimal point right there, right in the middle. You can actually put a big dot there if you want. Okay. All right, and how many are shaded out of 10 here? 1, 2, plus 5 makes 7. So this is 7.5. Okay, so this is equals. Okay. How many, now we're just looking at these. Somebody's asking, are we counting the holes? We already did. We counted the holes on this side. Now we're just counting the fractions. So this one has a possible 10, but there's only 4 that are shaded. So we put a 4 there. So this is 4 and 4 out of 10. All right, this one, here's the 1, but look at this. Yeah, does this happen in your house? Like somebody will put back, like they'll eat most of it, but like the last strawberry and then put that back just so they don't have to wash out the dish or whatever it is. Happens in my house too. All right, so they had eaten 1 basket and 9/10 of a basket of strawberries or whatever it is, right? Yeah, or there'll be a little bit of the milk left and they'll put it back so they don't have to handle it. Yes, we know who you are. And those of you who are like, it bothers you, yes, you're on my team right now. Okay. All right, so somebody's asking, can you do the fractions? Sure, okay. So this one here, this is out of 10. How many are shaded? 1. These are all out of 10. Do you see that? It's all out of 10. That's why decimals are so easy, because they're fractions where the denominator for tenths is 10. They're always powers of 10. All right, so this one is, we shaded 5, so it's 5/10. This one was 7, so it's 7/10. This one was 4, so it's 4/10. This one is 9, so that's 9/10. All right, how does that look? Does that look pretty good? Okay, so now what happens if we don't, suppose we have this, and it was our choice, right? We're the ones who got out the knife and we chopped the candy bar into, oops, not enough pieces, into 10 pieces, right? What if we had that same candy bar, but we chopped it even smaller, and so now there's 100 pieces in here? Yeah, so this would be tenths, right? That's 1 over 10. Each time you shade, it's 1/10, right? 1/10 of it. If these are hundreds, now each little box is 1 over 100. How many do you need to make a whole? You need 100, right? Because it has to match what the bottom is. So you need 100. So let me show you a better picture than this one. That's kind of my chicken scratch there. All right, so take a look at this picture. Okay, so we are on page number 10. Okay, go to page 10. Okay, so take a look at this top. And again, if you don't have the workbook, just borrow mine right now. Okay, so what this says at the top, it says here, in fact, let me bring the camera down just a little bit so you can see. Let me refocus just for a second. Hang on. Quick little intermission here while we do some technical arranging. Okay, is that better? Okay, so if we take a look, this is a chocolate bar divided into 100 pieces, but I only gave you 3. So this could be like 100 M&Ms, and I give you 3. Okay, 100 as a whole. This is 3. What if I give you 10? Well, that means I give you 1, so 10, and 100 is a special number, right? Because 10 times 10 is 100, right? So I can give you 1, I can snap off this part. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I have 10 stripes of 10. Okay, so this is the same as 1/10. And if I have 10 tenths, now I got a whole, right? So this is you eating the whole bag of M&Ms. Okay, so let's take it one step at a time. Take a look down here. This is a whole, this is a whole. So this is 1 plus 1, and that's the 2. Okay, so this is your whole number, 2. Then we put a decimal point. And we say, okay, how many sticks do we have? Sticks of 10. I have 7 sticks. And now this is 4. Okay? So look, 4 is on the end. Okay? So we're going to write 2.74. Okay? Oh, I made a mistake on the chocolate bars. I made a mistake on the chocolate bars. Oh, I did! Oh, thank you, thank you. Wow. Right? This is me doing math with a Sharpie. Wait, I'm so sorry. Here, can we go back to page 9? Here, look at me and my eraser. There we go. Okay. I am so sorry about that. Okay, so there's my 1 eraser. I made 2 mistakes. Yes, and is it okay to make mistakes in math? Yes, as long as, what happens? As long as you fix them. Absolutely. And you tell me, can you add this? 1, 2, 3, 4. 5. Yes, here's my second mistake. Thank you, thank you, thank you. We do read the comments, and your comments help. And if I make a mistake, absolutely correct me so I can show everybody. So I am so sorry about that. This is on page number 9. Okay, the mistakes, I'll put a highlighter around it so you can see it. It was right there. Okay, and I had just counted incorrectly. So I corrected that, and I corrected that. All right. Is that better? So I apologize. Thank you so much. Thank you, thank you, thank you. Okay. Can we continue? Are we good? Okay, so yeah, if you caught that, then you are spot on. Awesome. All right, so what are we doing here? So I'm going to tell you now there are 74 bricks. So this is 2 and 74. Okay, so this is one whole, and then what do we have here? I wrote the number in so you don't have to count them. 45. So you just write 1 and 45. And remember, because it was here, back when we had that right on page number 8, you remember? That second one was called hundredths. So we're just going to say the number and then say the word hundredths. So say it with me. 1 and 45 hundredths. So that's 1 and 45 hundredths. And when you say it out loud, then it's easy to write the fraction. So this is 1.45. Okay, how many holes do we have here? 0, right? Almost a trick question, right? So 0 and, okay, what's the fraction? 48 hundredths. So this is 0.48. So somebody's asking, can you just write 0.8 without the 0? The answer is yes. However, I have found in engineering that most students that make mistakes in their answer, it's because they didn't have a 0 in front and the decimal point got dropped because it's small and it's hard to see. Here, try it right now. Put a decimal point on your page in pencil, right? And then you could put a number next to it. Do you see how it's hard to see sometimes? And if you're running fast and have lots of equations on the page, it'd be easy to drop, okay? So I personally will put a 0. What I won't do is I won't do this because that thing is so big. So I will actually just put 48 hundredths instead. They're the same thing. If you want to put a 0, you can, but usually I can already see that this is nice and big. But it's just because I miss things. Yeah. Okay, because I'm a human. All right, so how many holes do you have here? 1, 2, and 3. Excellent. And then what else do we have? We have a decimal point. And then how many is here? 17. So we're going to say 17 is here. Okay. Somebody's asking, why don't you put the 17 here? It's one number per position. Okay. So this is 3.17. So 3 and 17 hundredths. So this one is 3 and 17 hundredths. All right, how are we doing? Yeah, the pictures really help, don't they? I would definitely agree with that. All right, you ready to add some decimals? Let's add some decimals. You are looking at page number 11, okay? Oh, and by the way, somebody's asking about the practical application. Yes, we are going to plan a party. Anybody like parties? Me too. Okay, so we need to do this part before we start planning a party. You'll have physical objects. And so at the very least, you'll have something like this. So you have to rewrite these things all the time. So let's rewrite this. So I'm going to write 3.5, and I'm going to line up the decimal. I'm just going to write the decimal first. And now I'm going to say, okay, there's a 2 there, and there's a 1 and a 1. Everybody has to stay in their own lane. You see that? Here, if I do this, actually draw some lanes. Everybody stays in their own lane. Okay, so now what do? We can say, we ignore the decimal point, and we just say 5 plus 2, that's a 7. 3 plus 1, yeah, shout it out, that's a 4. And a 1 plus nothing is a 1. Drop the decimal point, keep it in its own lane, and there's your answer. That's it. All right, watch this. What if I have $20 and I give it to you? You're real happy now, right? Okay, and I give you $2 more. How much do you have? Well, if you don't line up the decimal point, look what you have. Okay, so I have a 2 and a 2, which is a 4. I have a decimal point. Oh, and then I have a 0, and then I have another decimal point, and then I have a 0 and a 0. What number is that? Now you might say, oh, I have $4. You can't possibly have $4. You had 20. I can't add more to 20 and get less. You say, oh, no problem, Aurora. Now I have 40. Yes, but 20 plus 2 is not 40. So take your pencil and go like this, just to remind yourself. Do you see the zigzag here? And then it splits off, right? Okay, so we do not do that. Okay, let me back up the camera a little so you can see more of the whole page. Okay, right? Because that's not the way math works. Okay, so how would you do that? You would say $20. you'd line up the decimal point and say, okay, $2. Add them up, everybody in their own lane, 0, 0, dot, 2, and 2. So you have to use your brain when you're doing math. And if you make it really simple and systematic, you write nice and big, you have plenty of room, you're not cramped in a little tiny corner. You ever seen those math problems? And they'll give you the problem and it'll be like this big and they'll say, by the way, write your answer in this amount of space. Okay, so we do not do that. We have a math journal. You take all the paper size you need. You grab new sheets of paper when you need it. You write nice and big. I can't tell you how many times my students will make mistakes because they write small. So write nice and big, just like me. For this one, how about we do a negative sign? Okay, so again, everybody in their own lane, okay? So I have 8 cookies and you ate 2. We have 6 left. You made 6 cookies and I ate 1. We have 5 left. Drop the decimal point. There's your answer. Okay, nice and easy, okay? All right, so let's do some practical applications. What do you say to that? Would you say yes? Okay, meet me on page number 12. Can you do that? Meet me on page 12. All right, so here we go. I'm gonna give you a number. I want you to write it down. All right, you have $9.50. So write $9.50 right there. You have $9.50. Good. I want you to buy a cookie. Cookies are on sale. Anytime I see kids selling things, lemonade, cookie, doesn't matter how sour the lemonade is, my rule is you always buy it. Okay, so I found some kids. They're selling a cookie for $1.25. You buy a cookie. Okay, so we're gonna take $1.25. Do we add that amount to the $9.50? This is how much change is in your pocket. You buy a cookie. Does the money come out of your pocket or does the person give you a cookie and money? No, it comes out of your pocket, right? Okay, so put a minus sign there, draw a line. All right, now let's do some subtraction. Okay, so how do we do the subtraction? Here, I'll bring it down a little closer. How do we do the subtraction? Okay, so if there's a carry involved, it works just like regular subtraction. So if the decimal point's throwing you, just ignore it, okay? So just do this, 25 from 50. If you don't know what that is, you're gonna borrow from the 5, that's gonna be a 4. What is 5 from 10? 10 minus 5 is 5. 2 from 4 is 2. Just put a dot where you see a dot and then move on. 1 from 9 is 8. So now I have $8.25. Okay? Your mom is going to give you $2. She says, hey, I really appreciate you taking out the trash when I didn't even ask you for it, and I've got some spare change when I vacuumed the couch. Why don't you keep it? And she gives you $2. So do we subtract that or do we add that? Well, she's giving you something. We're going to add it. I know it's not lining up with the words, but that's okay. It's because I'm using a Sharpie. Yours probably lines up because you're using a pencil. Okay, and if it doesn't, that's okay. It's just you know what we're doing here. All right, so 0 plus 5, that's still a 5. 0 plus 2, that's still a 2. Drop the decimal. 2 plus 8, we call that 10. Now you have $10.25. Do you have more money or less than when you started? You have more. That's always a good thing at the end of the day. So you spent less than you earned. Would you agree? $1.25 is less than $2. All right, so how are we doing so far? Okay, we have one more piece to go. One more piece for decimals. Okay, and then we get to plan a party, like a real party, by the way. Okay, so let's talk about multiplying. Do you see how this is a little on the small side? Little on the small side. So if I were you, because it's on the small side mostly because I'm working with a Sharpie, so I'm going to do mine on a fresh sheet of paper. Okay, let's do the first one. 1 times 2 times 3. Now with decimals, if the decimal point is throwing you when you do I don't know my 1.2 multiplication table. That's not something I know. I do know my 12, right? Doesn't this look like a 12 if you'd put your finger over it? Now it looks like a 12. Okay, let's do that. So let's not do this one, but let's do this. Can you do 12 times 3? Okay. If you happen to know your 12 times tables or your 3, you might shout out 36. Great. Is 36 the answer? This is a little more than 1, and we have it 3 times. So 1 times 3 is not 36. So we're looking for a number about 3. So take a look at what we just did. The name of the game with multiplying and dividing decimals is you make the problem easier, like this, and then you put the decimal point back. And finding out where to put that pesky little decimal point is the name of the game. Watch this. How did I get from 1.2 to 12? What did I do to the decimal point? I erased it. Okay, that's good. I also moved it one hop this way. You see, there's always a decimal point at the end of a number if you need it. Okay, it's always there. You may not always see it, but it's going to be there if you need it. Okay, so for a whole number, even if the number's like 33, there's always a decimal point at the end, 33.0. Okay, so it's always there. Okay, so what do I have here? Okay, so I moved it one hop this way, and then I did my problem. Because I did one hop this way, I have to do one hop back. Okay, I have to readjust my problem. My answer is, if you put a decimal point between the 3 and the 6, it looks like this. And that is the solution to the problem. You didn't even have to take your calculator out. Look here, we can even do it on the calculator. 1.2 times 3 is 3.6. It's the same thing. Whoa, this is where you go, cool. Let's do another one. How about 1.1 times 5? I do not know my 1.1 times tables. So not something I managed to learn, but I do know this number. Doesn't this look like an 11? Yeah, okay, so how did I get from 1.1 to 11? I did one hop this way, right? One little hop. Okay, so 11 times 5, you can just shout that out. That's an easy one, right? Is 55. That's true. 1.1 times 5 is not the same problem as 11 times 5. So I adjusted it so it's easy. And now I just readjust it. There's a decimal point here. If I did one hop this way, I got to do one hop back. I have to readjust the problem. So this is equal to 5.5. This is probably the most missed thing on my physics exams that I grade. It's because the university students don't know where to put the decimal. So that's why I want to handle it now. What about this one? 0.9 times 2. 0.9 times 2. Okay. 0.9 is close to 1. Okay, but let's say we want to do this. Let's say we go one hop. Yep, I can already see you guys are working on it. Good, so it's one hop this way. So that's a 9 times 2. How did we get from 0.9 to 9? We did one hop, one little hop. Okay, 9 times 2 is 18. Now we're going to go one hop back, just like that. Okay, so this becomes 1.8. If this is making any kind of sense, can you put a smile on your face? If this is making any sense at all, even just a little, even if you're like, oh, I don't know if I could do this myself, that's okay. If it's starting to make sense. Okay, let's take it one step further. These are the last problems on the page, and these are the ones that most students will roll their eyes. Watch this. Okay, so everybody repeat after me. Yuck. You got it? Yuck, right? Who really enjoys doing these? Maybe a few people, but in general, it's like, ugh, right? Okay, so how about we turn it into a problem that isn't so hard? Watch this. 365 times 24. Now, if you're still thinking, yuck, well, this is easier than this. Wouldn't you agree? This one has decimal points, and I don't know where to put them, and right? Okay, so put your hand on it. Do you know how to do multiplication like this? Okay, hopefully the answer is yes, because if you're in a class on decimals, this had to come before. So this is a skill that you already know how to do. So I'm going to assume you already know how to do this multiplication. Can I assume that? Come on, say yes. Okay, so I'm going to tell you the answer is this, because you already know how to do 2- and 3-digit multiplication. Okay, I'm going to give you the answer. My question, because we're focusing on decimals, is how do you use that information here? Okay, because the numbers are the same. Look, 3, 6, 5, 2, 4, same numbers. The only thing is this one has a decimal point in it somewhere, and we have to figure out where. That's the name of the game. All right, so let's take it one step at a time. So how did I get from 36.5 to 365? What did I do to my decimal point? The decimal point is here, so it had to go one hop this way. So that's 1. 2.4 also went one hop, okay? So basically what I did is I got rid of the decimal point by making them appear here, right? These all have decimal points there, okay? Now I did 1 plus 1 is 2. I'm going to go 2 hops back, not 1, but 2, because there are 2 numbers here. My answer is 8760. Okay, and here, we'll do it on the calculator. So I have 36.5 times 2.4, and I get 87.6, 8760. Yay, right? Okay, here. You want to practice again? Let's do another one. Let's do another one. This is so much fun. Okay, so 19 point, well, it's fun when you do it this way, and 0.56. Good question. Do you have to line up the decimal points? No. In fact, let me not line them up for you. Ready? Let me rewrite that problem. Here, I will make it really, really obvious. So this one is 19.8 times 0.56. Because we're converting it to just be the numbers and we're getting rid of the decimal points, we don't care where the decimal points are. Okay, we're not dropping any decimal points down, right? We couldn't do this with addition and subtraction, but for multiplication and division, we don't care about the decimal points, so take them out. And then do your problem. Okay, do your normal problem. I will give you the answer because I already know you know how to do this. Okay, there's your answer to this problem. So 198 times 56 is 11,088. The question is, what is the answer here? So rewrite it like this, okay? Because the numbers are the same, right? 19856, right? So the numbers are the same. It's just, well, where's the decimal point? Okay, so watch. We do one hop here, 2 hops here. So 1 and 2 make 3. Here's the decimal point. You go 1, 2, 3. The answer is here. So my answer is 11.088. Should we check it with a calculator? Sure, no problem. 19.8 times 0.56 gives me 11. Oh, can you see that? 11.088. There you go. Would you like me to do one more? How about we do one more? Just you're comfortable. Just you're comfortable. Yeah, isn't this fun? Yeah, it's easier when you do it this way, isn't it? 8.52 times 4.9. Again, don't care about the decimals because we're about to get rid of them. Okay, so you write the problem. Can I do mine off to the side? You rewrite the problem, and then we'll compare. Okay, go ahead. Rewrite your problem. Take the decimal points out. You got it? Okay, did you get this? Okay, good. I'm going to give you what this is. All right. Now, I'm not going to say anything. I'm going to do it down here. Okay, so I'm going to give you this. This is 41748. You tell me where's the decimal point. So write the number. And you tell me, where do you think the decimal point goes? I'll give you 10 whole seconds. Go, 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 go. Okay, and this is the very last thing we're doing before we plan a party. Okay. Did you get it? All right, how many hops here? 1, 2. How many hops here? 1. We go 1, 2, 3, and here. For those of you that are more advanced, another way we make sure we don't make any mistakes is we ballpark our answer. This is about 8, this is about 5. 8 times 5 is about 40, and that is the answer that we get. Okay, you could do it up here too. This is about 20, this is about a half. Half of 20 is about 10, and that's what we got. So ballparking our answer is going to help us, especially with decimals, to make sure we don't make any mistakes. Like I did on the other page. Yay! All right, good job. So how are you feeling now? How are you feeling? You realize how much math we've been doing. We did fractions, we did decimals, so you know what that means. It is time for a party. Who wants to come? Okay, so here's what I have for you. Let's plan a party. I'm going to give you a second math challenge, and then if you want an extra 5 or 10 minutes of just talking about percents, we'll do that. But if not, honestly, you have done so good today. So good today. All right, so why are we having a party? Because parties are fun, and we have to celebrate your successes. Imagine if you only work, and you never celebrated. Would you be that excited about working some more? So even in my math program, we actually have parties when we are done with a certain segment. We have 5 parties throughout the year, for this year anyway. When we finished fractions, we had a party. And so it was so much fun. We had, everybody was laughing and just having a great time. And we had some math challenges and secret codes and ciphers. And anyway, it's super fun. So let's plan a party. Let's plan a real party. So I want to know from you what's the best way to ask this? About how many people do you want at your party? How many people are you comfortable with at a party? Okay, so think about the kind of party you want and how many people you'd like to invite, and let's go ahead and plan it. Let's plan it for real, okay? So this is a real hands-on, a real approach, And we are on page number 13. Okay, so we are planning a party. You ready? Real party. All right. So you have a job, and you can tell me what that job is. Do you want to mow lawns? Do you want to pick flowers? Do you want to deliver cookies and bake cookies and deliver them to customers? Do you want to make smoothies? Do you want, like, what kind of job do you want? Do you want to play with puppies and kittens at the animal shelter? Like, what kind of job would you like? Yeah, there's lots of jobs for kids. Absolutely. My kids have pretty much always had jobs of this, of some sort. They've always been busy learning and doing things. Okay, so I'm going to say at your job, let's suppose you're a little bit older. I don't know exactly how old you particularly are right now. You don't have to tell me. I'm just going to make some assumptions here. All right, so let's plan a party. I'm going to say that you found a job that pays $15.50 an hour, and you worked for 16 hours. How much did you earn? Okay, yeah, hello decimals, right? So you can write it up here, $15.50 every hour. Doesn't that sound like a lot? Okay, and you worked for, so if you work for 1 hour, you get $15.50. If you work for 2 hours, you're going to get twice that. If you work for 3 hours, you get 3 times that, right? So if you work for 16 hours, it'll look like this. Yes? All right, do just what we did before. Convert this, 1550 times 16. Okay. So how many hops did we do to get this to look like that? We did 2 hops. That's right. Okay, so just keep that number in mind. All right, I will give you the answer to this. 24800. So how much money did you earn? All right, so 24800, you did 2 hops. That means you're going to come 2 hops in. You earned $248. Okay, and you did that, say, in 1 or 2 weeks. Okay. All right. Oops, wait a minute. Don't put that there. Ah, do you have an eraser? Sorry. All right, erase that. Sorry. So this is how much you earned from work. Okay, $248. In your piggy bank, you counted $127. Okay, so we're going to add that because this is how much you earned working, and then you've been saving money from before. And now this is how much we are going to have to throw a party. So go zeros, and we have more zeros. Drop your decimal point. That's right, we're adding decimals. 8 plus 7 is 15, so put the 5 there and carry the 1. 1 plus 4 is 5. 5 plus 2 is 7. No carry, so that's just a 2 plus a 1 is a 3. Go ahead and take your pencil and write a big old box around that. We have $375 to throw a party. Does that seem like a lot? Yeah, so I'm going to call that our party budget. Budget just means a plan for your money. Okay, so we have $375. We can choose to blow it all on a party. We can save some, whatever you want to do. I'm going to choose to blow it all. Okay, because this is, I don't have any other expenses, and I know next week I'm going to make another $15.50 an hour, and I'm scheduled for 16 hours. So I know I'm going to have more money next week. Okay, so I'm okay spending this on a party. Here's question number 1. Cake. Now, you and I know that if you go to a grocery store and we get a cake, one of those big fancy cakes, those things can be expensive. So I called the grocery store. They said they're happy to sell me a cake. It was a sheet cake, so it was a big rectangle, and it was $22. So if you would like the $22 cake, you're going to write it here. I also went to the grocery store to the baking aisle, and I found for $5 I could get a $2 cake mix and $3 worth of sugar and butter to make frosting. So what do you want to do? Do you want to spend $22 and have them do it for you? Or would you like a $5 cake? Either one is fine. You write one of these down. So write the one that you want, okay? Whichever one you want. By the way, the cake is the same size. Same size. Okay? All right, so these are real numbers that I got. All right, so then I went to, we have a dollar store, which means things are $1 or $1.25. And I went to the dollar store and I found for $5, I could get 2 packs of balloons and 3 packs of streamers. So decorations, basically. Okay, and I can get them in the color that I wanted. I could spend $5 and get balloons and streamers. Then I went to Target, and wouldn't you know it, they had a party bundle that was a theme. Wouldn't you believe it? About the same stuff. They were all patterned and colored, and they had glitter on them. It was $75 for balloons and streamers. I know, right? So which one would you like? Either one. I want you to write whichever one down. There's no wrong answer here. So please know that. If you want to spend so this is how much we have. You tell me how you want to spend this amount. This is yours. You make a decision. Okay, so it's not always, the answer isn't always like, oh, let's just pick the cheap of everything. Well, you earn this. So what is most important to you? That's what you write down. If you're not sure and you want to write down all these options, you can go back and circle the ones after I lay them all out. That totally works too. All right, pizza. All right, I called up our local pizzeria. They said it was $15 for a large, and a large has 12 pieces. Okay, so just write that down, $15 for 12 pieces. Okay, see, it's getting a little complicated, right? All right, that's why we're doing this. And then back at the grocery store before I left, I took a look at the sodas I like, and it was $4 for 8 sodas. All right, so these are our options. We can spend most of our money on streamers if you want to do that. We could buy tons of pizza, right? So we have options. So these are things that we know we want. We want cake, we want some decorations, some pizza and soda. Pretty standard for a party, right? Okay. Now let's take a look at some of these other things. All right. Now when the people come over, they want to do stuff, right? So I called around and I had, these are real numbers. Magician said $150, and he says, by the way, I will do my show for any size. So you could have 10 people, you could have 100. It didn't matter to him. $150, and that's what you would pay him. Skate park is free. You could have any size party. People just bring whatever they have that has wheels on it. They show up, and it's free. That could be an option. Soccer game. Okay, so we have Coach Dan is one of our family's favorite coaches. I called him up, and he said, sure, no problem. I will come to your party. He says, no more than 20 kids, though, otherwise it gets a little crazy. He said, I'll be there for 90 minutes, and it'll be $40. Okay, so he'll be there for an hour and a half. And we could just literally get pizza and soda and a soccer, and he's like, just pay me $40 and I will handle that. Bounce house place. They were the hardest to get a real answer out of because they were wanting to get my credit card number. I said, just tell me how much it is. They're like, sure, go ahead. Let me get your credit card on file. I'm like, no, I don't want it on file. How much is it? So eventually I got it that it was $250. And they said, by the way, no more than 12 kids. Have you ever been to one of these bounce house parties? You tell me how easy it is, little kids now. Is it easy for them to understand taking turns, or do they like hog it? Are there like usually a group of people? Yeah, they hog it, right? They don't want to take turns unless you bribe them with like chocolate or, cake, right? Cake and ice cream. And suddenly everybody's out of the bounce house, but then they run right back in and now they bounce even faster because they're full of sugar. Okay, so I knew that if I picked a bounce house, that would be the limit. That would cap the party at 12 people. All right, and then I called the laser tag rental place. They said, sure, no problem. It's $300, 8 people, and by the way, you only have it for an hour, 60 minutes. Okay, so we have some decisions to make. Do you see how this is, it's hard. You got a lot of pieces here. That we have what our budget is, which is great. Here, I'll put it like this now. Okay, $375, and I can split that up into lots of different ways, right? There's no one right answer. I could spend more on a cake or less, more on streamers or less. How much pizza do I need? Well, it depends on how many people are coming. How many people are coming depends on what kind of activity we have. Do you see how it's all related? So writing this stuff down could really be helpful here. Okay, so you're going to have to make some decisions. You make your decisions, whatever it is. Think about the kind of party you want, and I want you to circle it right now. Circle, and there is no right answer. I'm going to demo because we have to write something down. So I'm going to choose a magician. I think that would be really fun. And I want the kids to get their energy out because I know they're going to be wild and crazy. And so I'm going to say this. So this guy, so the question is, how many people can come to my party? Well, this guy said in as many as you want. This guy said 20. Okay, so now I know, based on my choices, that I have 20 kids at my party. 20 kids. Okay. So now I can start to use that number to figure out how much pizza, how much soda, right? How much cake, right? How many cakes do I need? If I have 100 people, I might need more than one cake. Okay, so this is me deciding. You decide what you want. But for this purpose, if you want it to match what I'm going to write down and you're writing down what I'm writing down, then pick these. But again, know that there's no right answer. So you pick what you want to do. Okay. So let's do our party planning. So page number 14 is the last page for this activity before we do another challenge. So we're on page 14 and it's pretty much blank. So party planning. So how much do we have to spend? I want you to write $375 at the top. Okay, now what do we do? All right, now we know for sure we have some fixed costs. Fixed costs are things that doesn't matter how many people are coming. So which cake did you decide? I'm going to decide on $5 because I like baking. So this is going to be fun for me and I get to save money too. So this is the cake. So we're going to subtract. So somebody had asked, can you please do more subtraction with decimals? Here it comes. 5 from 5 is 0 and the 37 simply drops down. So I had $375. I spent $5 on a cake. I have $370 left. What else is a cost? Okay, balloons and streamers. I'm gonna spend more of my money on the magician and stuff and less on the decorations because I think that kids don't notice the decorations nearly as much as they do like a soccer ball. So I'm gonna choose balloons and streamers. So here, I'll circle this, I'll circle this. So $5. So I'm just gonna put deco for decorations. Okay, so 0, 0, decimal point. All right, so 5 from 0, you can't take 5 from nothing. So make it a 10 and borrow here from the 6. So now I can write down 365. So that's how much money I have now, $365. And I've got my cake and my decorations done. How much pizza? Ooh, well, how many pieces can you eat? You can tell me right now, how many pieces could you eat of pizza? It depends, right? How much candy and how much cake. I mean, what else is there, right? You're going to have pretzels and snacks and chips and salsa. I mean, it depends. All right, so I'm going to say, actually, you know what? I'm going to say, I know what the magician and the soccer is going to cost me. Let's do that, and then let's see how much we have left for pizza. Okay, so I'm going to say from $365, the magician was $150. Okay, so that was magic. All right, so 0 and 0. 0 from 5 is 5. 5 from 6 is a 1, and that becomes a 2. So after I pay the magician and after I buy the cake and the decorations, I have $215 left. And I also need to pay for the soccer coach. And so how much was he? He was $40. Okay, so we're going to continue to subtract. See how quickly money leaves. So here's some zeros. Drop the decimal point. 0 from 5 is a 5. Can you do 21 minus 4? Can you just do that really quick here? Like this, 24 from 21? What would that be? 4 from 21? Okay, so that would be 17. Did I get that right? 175? All right, so that's how much I have left. What else do I need to do? Okay, so I got the magician, I got the soccer. Okay, so now it's food. How much pizza and soda? Well, I don't like wasting food. So I want to make sure that we have enough, but not too much. Okay, so I'm going to say for me, for 20 kids, just from experience, I'm going to say that's going to be 4 large pizzas. So how many slices is that? That's going to be 4 times, there's 12. So that's 48 slices for 20 kids. So every kid can have at least 2. And then maybe a few kids will have more. Maybe a kid won't. Yeah, there's always a few kids that only want 1 or don't eat at all. I don't know how they go. They just like run on air. And so there'll be a couple for parents too. So I might say, so that's 48 pieces that we have. Okay, so how much are they? They are $15 each, right? And I need 4 of them. So 15 twice is 30. 30 twice is 60. So this is going to be $60 for pizza. All right, so I'm going to say minus 60. So that's pizza. Somebody's asking about ice cream. Yes, you can buy ice cream if you want. We're just going to focus on this right now. Okay, so 0 and 0. And so I subtract these numbers. So 0 from 5 is a 5. 6 from 7 is a 1 and a 1. Okay, what else do I have to buy? Did I do it all? Let's see. I did this. I didn't do the sodas. Okay, so how many sodas? All right, there's 8 sodas. Every kid will probably drink less than 1. If you've ever cleaned up after a party, you know most of the sodas are left over in whatever you had, right? They'll take like 3 sips and they're done. So that's just from experience. So I'm going to say every kid gets 1. So 2 times 8 is 16. That's not enough for everybody to have 1. 3 times 8 is going to be 24. Ah, that's what I want. So I'm going to have 24 sodas, 3. But it was 3, I'm going to get 3 packs. has 8 sodas. That'll give me 24 sodas. So each pack is $4. So 3 times 4 is $12. Okay, $12. So how much do I have left? 0, 0. I have a 3 here, and I have $103 left. So take a look at what we did. I have a cake, decorations, magic, soccer, pizza, soda, and I still have $103. All right, how many people are seeing this is like a real life example right now? Yeah, you're kind of seeing that? Okay, here, let me back up the camera for you so you can see the whole thing on one page. Okay, yeah, real life example, right? So what did we just do? We started with how much money that we had. Let me straighten that camera out a little bit. Okay, how much money we had to spend. We spent it on cake, decorations, magic, soccer, pizza, soda, and look, I still have some left over. Let's do something with that. Can we do something with that? You bet. Let's go back to the dollar store. Watch this. Let's round 103 down to $100. How many kids are coming? Do you remember? How many kids? Yeah, there's 100 kids coming. So, or 100 kids, I'm sorry. We have $100. We have 20 kids. I'm talking too much. 20 kids. $100 divided by 20 kids. 20 into 100 is a fraction. 100 divided by 20, it's a division problem. That's going to give me $5 per kid I can now spend on party favors. Party favors, that's right. What kind of party favors can you get? Well, I went to the dollar store and I took a look. I could get a bag of marbles. I could also get, for $1, I could also get, I think 10 dice. I could get 2 packs of cards for $1. They had little pocket magic tricks. I thought that would go with the theme of the magician. Okay, and then they had little tiny soccer balls. They were super cute, and you could get 1 soccer ball. That's supposed to be a soccer ball. Okay, I can get these little handheld ones. You've probably seen them. And then I could also, they had little soccer balls of chocolate. Chocolate, like that. Okay, so there were 20 marbles here, there were 10, there were 2 here. So I could get a bunch of these, break them into pieces, and put together little sacks and spend no more. I would not spend over $100, but just make sure that this amount of stuff was less than $5 a kid. Now, wouldn't this make a good party favor if it had some of all of that stuff in it? Yes, and you spent less than $5 per kid for a party favor. Yay, we did it. Okay, so what did we do? We planned a party. Let me get my other one. Okay, we planned a party for 20 kids. We added and subtracted decimal numbers. We took a look at adding decimals here, step by step. We took a look at how decimals were built, and we also started off by relating fractions with decimals and by looking at tenths, hundredths, and we just mentioned briefly thousandths, and we did that all in 40 minutes. Yay! Okay, this is like the longest math class ever. Can I give you a challenge? Yes? All right, so stand up, shake your body out, shake your body out. All right, so if you're wearing like 2 t-shirts or a t-shirt and a sweater, you're set. If you're not, stand up, run, go put a sweater on, no buttons, but like, or just put another t-shirt on because you're gonna take it off. Okay, so this is the challenge. This is the challenge. So get up, go get like a pullover sweater. Okay, so you want a sweater on. Okay, so you need 2 layers on. That way you're not naked when you do this math problem. Okay, all right, so go ahead and put on a sweater. Go ahead, I'll wait. Here, I'll answer a couple of questions. Yay, I can really use this for a party, yes! How do we get out of the handcuffs? I will answer that, I promise. All right, okay, so how many of you guys are enjoying this? Can you tell me right now how you're doing with a 2-hour math class, right? 2 hours. So I think what we're going to do is, I think we're going a little long. So what I'm going to do is I'm going to record, I actually pre-recorded the percent part, which is only 10 minutes, but I think we're going to stop here, and I actually have that right now. I'm putting it up on the recording page, and so you can have that, you can watch it if you want. So it's just the last 2 pages that we had gone through, but since we are going so long here, I'm just talking while I'm waiting for the kids to get a second shirt on or sweater. These 2 pages, I actually I recorded it just in case I went over which we did. So you'll have that, and it has the this bonus page has in it the answers to everything we've done today in the homework packet. So in the worksheet we've been working through, and it also on your worksheet. So parents, can you just grab that workbook they've been working on? Look at the last 2 pages. These are for you. These are not for the, well, I guess they are for kids, but you're gonna have to take your kids to either the library. If you want math book recommendations, these are some of my favorites. There's a math dictionary, Mysteries with Math, Kitchen Table Math, Secrets of Mental Math, and if you want a practical, hands-on way of your kids understanding how a computer thinks and does its adding and how it works with numbers, there is a marble computer down here that you can get. It is so cool. Basically it's binary counting. It's how a computer does its calculations, and it's super fun, and I put it down here, and there's a direct link into it, into these. None of these are affiliate links. This is just me saying these are my favorite resources. This is for you. And then also parents, if you're interested in doing more lessons above and beyond what we've done here, and you want to learn more about the some mathematicians that are my personal favorites, then page 17 has them all listed. Take this to the library and you can learn more about these people as well. So yay. All right, kids, you ready? All right, come back. All right, you got your sweater on. All right, if you don't have a sweater, somebody's saying they don't have a sweater, just grab a second t-shirt and put it on. It's easier if it's short sleeves, but if you want to use long sleeves, it'll totally work. Doesn't matter, short or long, it'll work fine. All right, here we go. Grab your string. So you've got 2 layers on, yes? Nod your head, yes, okay. What you're gonna do is you're gonna handcuff yourself just like this, just like this. You're not going in and out or under anything. You're separate from your neighbor. Okay, you are all by yourself. All by yourself. You're not stringing this through a stuffed animal or the chair or anything else. All right, you're just like this. Show me your hands. Okay, you got it? Now, your job, are you ready for this? Are you sure you're ready? Okay, let me read the exact instructions so I get it correct. Is there any, because I like to phrase it as a question, so I wrote it down. Is there any way you can take off your sweater, turn it inside out, and put it back on again without taking your hands out of the handcuffs? Okay, let me say it again. Is there any way that you can take off your sweater, turn it inside out, and put it back on without taking your hands out of the handcuffs? So you actually will be wearing your sweatshirt inside out, and it's back on. And the question is it going to be forward facing or reverse facing? Ready, set, go. So again, you're wearing 2 layers, you've got your handcuffs on. Now, is there any way you can take off your sweater, turn it inside out, and then put the sweater back on without taking your hands off the handcuffs? Do you use the rope? Yes. Okay, so parents, stay here. I've got a whole bunch of questions parent questions came in from when I talked before. Students, you get 4 minutes. 4 minutes. We have to wrap this class up. This is like the longest class ever in math, right? That you guys are still laughing about and having fun. All right, so parents that are asking for the slide again, let me put that back up for you. All right, so really quick, really super quick. So parents, if you are interested in the program, I highly encourage that you take advantage of the offer right now. There is a big button that is below. Click that. And while the students are doing this, parents, can everybody click that button right now, because I'm going to show you where the bonus section is. Everybody should click the big button below, because it will say something like click to enroll and get bonuses. Here is your bonus. Okay, so click that big button. I actually have mine here. I'm going to share my screen with you as well. So what you're going to do is you're going to click to enroll and get bonuses. Okay, so you're going to click on that link, and it will look like this. There we go. Okay, so the page looks like this, right? You got that page. Now you're going to scroll down. Do you see how I scrolled? It didn't actually fit on a whole page for me. It says click here to access bonuses for the math class. Click that. And dun da da da, here is the bonuses for the math class. This is the recording from right now from fractions. And then we just finished decimals. Is my team good or what? And then I also recorded myself doing percent in advance. You'll find that here. And then if you would like the answer key to the workbook, it's right there. And then parents, not kids, parents are watching right now. Just keep scrolling. Here is the jailbreak. And at the end of this, I actually show you how to get free out of the jailbreak. Okay, so the first part is how do you handcuff your kids? And the second one is how do you get out of it? Okay, so how did I get to this? Let me show you again. So you go to, there's a link below this video. It says click to enroll and get bonuses. Click that link. Everybody clicks that link. When you do that, the page looks like this. Scroll down till you see it says click here to access bonuses from the class. Click that button. This page will appear and it looks like this. Okay, and this is where I have all of the bonuses. So you have the fractions class now, you have the decimals part now, you have percent, which we didn't get to because we ran out of time, I'm so sorry, but it's there, and the jailbreak is there. Okay, so you can take a look at that. Is the inside out sweater? No, I didn't post the solution yet because you're in the middle of it. I didn't want to give it away. You've already had time to do jailbreak, so you can take a look at that. All right. So let me answer a couple of quick questions. Yes, I know this is fun. Which one do you like better? Do you like this one better? Okay. All right, so going back really quickly, just to outline a couple of quick things and highlight a few things. If your kids really learned something from today's class, if they had fun, if they are getting some ahas, that tells me they are probably going to thrive with my math program, my Supercharged math program. Remember, when you enroll today, you're going to be saving over $1,300 off the regular price of the curriculum, plus the bonuses that you're going to get to receive. Everything that's on this page is yours. And your special price today, you can't get this from anywhere else on the website. It's only here. You can't Google search it. It's not on my website listed anywhere. It's right here, right now, just for you. It's $87, or if funds are tight, split it into 6 monthly payments of just $16 each. Either way, you'll get enrollment to the Supercharged math program that starts today and will continue all the way through now through June 1st of 2024. And those bonuses again, the live Zoom class with Aurora each week. Kids can use it for the price of one. How to master multiplication tables in one day. How to memorize almost anything using a 100-year-old secret code. Math tips and tricks by making learning fun and easy. And how to quickly add and multiply in your head. So if you are ready to give your child a chance to learn math better than ever before and enjoy this whole learning process, you want to click the button now. And remember, you're saving over 75% off of everything that's listed here. And it's got a full 30-day money-back guarantee. Try it, see if it works. If it works, great. You stay on board. If it doesn't, no problem. You'll get a full and complete refund. We're still friends. It's not a problem, but you got to let me know within that first 30 days, okay? So I look forward to working with you and your child. If you have questions, I'm going to stay here because right now I'm going to give away prizes. I'm going to give away prizes. So, all right. So students, ding, ding, ding. You ready? I told you, 4 minutes. All right, come back. The ears should be pricking up now. Come back, come back, come back. Even if you're like inside out and tunneling in your sweater, just listen to me right now. You can have your parents type for you if you need to. I'm going to take 2 winners from right now. You're going to type the answer in the box. In the box. I'm going to tell you the question, and while you're typing, I'll show you what the prizes are. In the box right now, you're going to tell me the coolest thing that you learned in today's math class. Coolest thing. It doesn't matter if it's not cool to anybody else. Your aha moment that you got that you are so excited about from math class today. You're going to put it in the comments right now. All right, so go ahead and do that. You can just shout it out and have your parents type it in. That's totally fine. All right, I'm just going to randomly pick 2 people, and then I will be in touch with you. Make sure that email is in there, or I can't get you a prize. So I'm going to physically mail an envelope in the mail to you. The envelope will look like, it'll look like one of these envelopes. Inside this envelope will be my very absolute favorite from back of when I was a young engineering student. It will be my favorite engineering ruler. It looks like this. You see it? It's got a protractor on it in addition to metric, standard, and grid lines. We are going to be using this in my 7-week intensive geometry class, which you were invited to because when you sign up for the program, you get access to that. So that's going to start in a few weeks. This is coming your way. The other thing that I have for you, dun, da, 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 hang on a second, let me reach it. Oh, there's 3 things, by the way. The second thing, oh, those are the wrong ones. Wait. Here, keep typing while I'm rummaging. The second thing, I don't know if you can see this. Here, I'll put it right up to the screen, is I have hey, you did awesome in math today. We have a pin and it says math on it. It has a picture of a compass and it has a picture of some things that says math on the bottom. So this is going to be yours. So if that looks cool. And then my third thing is probably the thing that kids like the most. So let me, hang on a second. I have to stand up to go get it. All right, so I'll make this nice and big while I stand up and walk over. The third prize that is coming to you, and you actually get to tell me which one of these you actually want. So you can pick the 20, the 12, or the 10. It's going to be your choice. And here, I've got them in my hand. Let me show you one of each. Oh, I do have a 6. I have a 6 if you want it to. All right, so I have a 12. Let me get a 20. And a 10 is way on the bottom. Of course it is. Just empty them all out. There we go. All right, so there we go. Okay, so I have that one, and that one. All right, so let me actually just bring you over to my desk really quick. So you will get to pick one of these. So these are double dice. There's dice inside of dice. So this one has 20 sides, 12, 10, and a 6. So you can tell me which one you'd like me to send you. That's going to go as well as the math pin that we give as awards in our math class. So those are the prize. That's the prize for today. You'll get one of these, this, and this. So you get 3 things in your packet. All right, so you are typing in to me. Type, type, type. You're typing in like crazy now. Okay. All right, so I'm going to answer a couple of questions to give you a few minutes to type it in, and then I'm just going to randomly pick a prize. Don't make it too complicated. Just tell me something that you enjoyed today. So students, also your homework is, well, I'll tell you what your homework is in a minute. I have a fun homework for you. You have to get free of the handcuffs. That's the first homework assignment. Okay, so how do they solve the handcuffs? Don't forget that solution is in, you watch the jailbreak video. It's at the end. It's the last 30 seconds, and I show you how to get loose of the jailbreak, okay? All right, so you want to click on enrollment and get bonuses. Okay, other questions that are coming in. So parents that are asking about being a vendor for their charter school, no problem. We do accept POs. And so, but that has to be set up from our side. So you want to let me know, Aurora at superchargedscience.com. Drop it in the comments, make sure your email's in there, and my team will get in touch with you. How many questions do you have now? I have 1,459 questions in the queue. So we do go over each and every single one. We basically chop it in half, and me and my assistants work through it. It takes us a few hours, but we do go through every single question. Okay, and so if you, cool prizes, I know, right? I told you it was a party. Okay. These are prizes you can actually use. Okay, so other questions is the worksheet, where's the answer? So remember, you're clicking, everyone is clicking the click to enroll, that button below. Everybody's clicking because it says enroll and get bonuses. This is the bonuses part. So, well, I know the bonuses are also in the slide, but this is the bonuses that we're talking about. So click the button and then scroll all the way down and then click it. It says click here to, what does it say? It says click here to, oh, I'm going to have to look at the actual words now. It says click here, so enroll and get bonuses, yes. And then it says click here to access the bonuses for the math class. Click on that, and then that page will open it up. The recordings are there, the answers to the workbook are there, the extra part and percent that we didn't get to. I'm so sorry, but it is there. It's only 10 minutes, it's really short. Okay, and somebody's asking, can I rewatch the fractions? Yes, this is my gift to you, and it's just, even if you don't enroll in my program, you get this page. This is for you. You also get the workbook packet, which has the 2 bonus pages at the back as well. All right, questions. If you have a special situation, absolutely let me know. Aurora at superchargedscience.com, or just put in the comments. Remember, the comments are private. No one else sees them but me. So, and yeah, we do that for privacy reasons. Oh, obviously, some students were upset. They're like, I want to see other people. Yeah, I'm sure you do, but this is private, okay? And so just know that whatever your situation is, we will do our best to help you out, okay? So whatever it is you're looking for, the link for PayPal, the POs, the vendors, you have more questions about the program before you enroll, let us know so I know what kind of information to provide you with. Okay, great. Is the program new? Yes, it didn't exist. This time last year, I was telling people, hey, I'm thinking about doing math. Anybody want to join me? And basically, I asked people to sign up before the program actually existed. And we had so many people. When we started in September, they said, I had no idea it would be this awesome. And I was like, yes, I'm so glad, because I didn't know. It was an experiment. I wasn't sure if anybody would like it. I didn't know if anybody would sign up, right? Sign up for something that doesn't exist, right? But I've been doing science for 20 years, so they knew me, which was great. But at the end, it was, they had said they like, normally we teach math with science, because that's where it belongs. That's where we use it. But this is the first time I'd ever taught math all on its own. And so kind of just a little backstory, I wanted to make sure that the math could stand on its own enough and be enough of a program for people to be happy with. And so that's why we're teaching it in this different way. And somebody's asking about Common Core. Yes. So if you need to comply with Common Core standards, then this program, how do you say this politely? It'll blow all of the standards out of the water. Your kid is going to be more than prepared. In fact, if I can tell you a little secret, a couple of weeks ago when we started algebra, I had said very specifically, make sure you're not just pushing your kid, right? You want this to be a happy, positive experience because we're in this for the long game. We want them to be happy, excited. We want them to come back and do even more, right? So don't just rush for the sake of rushing. So I had said, make sure that your kid has a really good grasp of fractions and decimals, just like we talked about here. I said, before you start algebra. And I said, it doesn't matter how old they are with algebra. You can start at any age. The principles are the same. It's just when they are ready. Some kids are ready earlier, some not so much. So a mom had sent in a picture of her kid a few weeks ago. And she said, I just want to show you my child who's 7 years old. 7, right? 7. 7 years old, started your algebra course. She's happy with it. She's learning. She's understanding. And she goes, and I tried to trick her and change some of the problems on her. And I'm like, are you kidding me? And she goes, and my daughter didn't fall for it. She goes, I tried to change the answer key. And she goes, and she didn't bite. She knew that was wrong, and she knew her answers were correct. And my first thought was 7. And my second thought was, yeah, you go. You show your mom you know the answer. And then I was like, algebra is hard enough as it is. Why don't we encourage her a little more? So anyway, that kind of made for a funny story, like, oh, okay. So anyway, so the bottom line is that you start when your students are ready. And so even though we say grades 4, 5, and 6, what we're saying is for the lower level, it's going to be fractions, decimals, percents. With all kinds of applications and practical applications, word problems, all of that's going to be in there. And then for grades 7 and 8, we're going to focus on algebra and geometry. So those are the big areas. So if you have a 7th and 8th grader who still doesn't have fractions, decimals, percent down, I would recommend maybe even getting both or just getting the lower one first. So it's independent of age and grade range because it's based on when your student's ready. And so and what they know, what they already know. We've had some students that are in high school that are attending the class in decimals. So it's really up to you. You need to meet your student where they're at and kind of iron out the wrinkles where that is, and then they will be able to catch up. You'll be amazed at how quickly they catch on because the stuff starts really, really making sense. So please hear me on this. I say grades 4, 5, and 6 because traditionally that's when it's offered. But if you have a student who's struggling, absolutely, you can grab the younger package. That works as well. If you've got a student who's excelling, grab the older package. And so it's going to be up to you. We do give you a discount. They will be 2 separate programs starting in September. So starting in September, I'm going to be teaching fractions, decimals, percent over an entire year in the live classes. We'll start with fractions, we'll go to decimals, and then we'll end up the year with percent. And there'll be some mix and match throughout the year. And then we'll also, in September, start with algebra. And then we'll move into geometry after winter, or in the middle of winter. And we'll so each one will have its own set of live classes. Okay, does that give you enough time? Okay, all right, so I'm going to randomly pick people. Here we go. I'm going to close my eyes, and I'm just going to pick a number. That's probably the easiest. I'm just going to write down 2 numbers, and that will be your number that you are in the queue. Let me get a piece of paper. Okay. All right, I've got my numbers. Let me go ahead and just write. Ding, ding, ding. Here we go. All right, 3, 2, 1. Winner number 1. Okay, people are already submitting their addresses. I love it. It was just your email address I needed so I could get in touch with you. And people are already getting there. Send it to me. One person went, me. Oh, you guys are the best. You are the absolute best. You make this whole thing so fun. Okay, does algebra include pre-algebra? Yes, it does. It does. We actually start the first 2 weeks of algebra is pre-algebra. Okay, so the first bit. So yes, we will be doing this. Okay, how long is this available, this offer? So the offer is now. I'm going to call 2 winners, answer a few more questions, and then we're done. If you have special circumstances, let me know so I can be helpful to you and your family. Okay, so here we go. Oh, whoops, I made the whole thing go away. Hang on. All right, I have winner number 1 is, let me see. I can't pronounce your name. I'm so sorry. So I'm going to spell it. Here we go. Kyrie. Is that Kiri? I'm so sorry if I mispronounced it. Yay! Okay, so I'm going to highlight you so I know I've got you done. All right, you are the winner for one of the prizes. Congratulations. And our second winner, so let me write down your name so I have it. Let me get another piece of paper. Hang on, that was my first winner. Okay, perfect. And then my second winner is, dun, da, da, da. Oh, we had people in here that did more than one. Oh, I see you. You're only supposed to submit once. You're only supposed to submit once. Okay, so let me go ahead and pick my second winner. So my second winner is, dun, da, 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 is another one I don't know how to pronounce. Okay, it is, let me write down the name. Can I spell it? Okay, it is Noorsham. Yay! So yay! All right, so my team will get in touch with you. If you want to just send me an email and say, I won. I know your actual emails, so don't pretend like, hey, that's me, and it's really not. I know you. But you can, I have both of your emails. We're set. I will send that to you as a prize. Thank you so much. If you would like to know where I bought these things, because you'd like to get them for your students, you can get them from Amazon. I don't know where you can get the pin from, but it's called Double Dice. And then the other one is a protractor ruler. So just look for that. It's a 6-inch protractor ruler. So both of those things, and they're not that expensive. So it's not like, $100 price. So you can get those. Okay, so let me go ahead and see about other questions that are coming up. Yay! I like the party planning. The party planning I think was the best. The party planning and road trips are definitely the people are putting in me. I see that because I announced it. Okay. All right. So we have, let's see, can my child access the program instead of being in front of the computer real time? Yes. So everything is recorded. Do you want me to show you what it looks like really quick? So this will be the last thing we do here. Here is the online program. This is actually what it looks like. Let me move the names and stuff. Okay. So this is what it looks like here. And what you do is, say for example, you just started and you want to start fractions. Suppose your student has not had fractions yet. I'll tell you what to do if they have. Okay, you're going to click on fractions, and then that will take you to the main page for fractions, and it'll talk to you about what it is and what we're going to be doing. It's each unit, fractions, decimal, percent, algebra, it's divided into 7 study blocks. The first study block says fractions week 1, so you click here to go to fractions week 1. Okay, so let's do that. So we're going to click on that. And then what we do is there is an intro video for parents. This is me saying, hi parents, this is what we're going to be learning on this page. So in this study block, in this week, you can take more than 2 or 3 weeks. You can take 2 or 3 weeks to do a one session here. Okay, it's up to you. I just called it week 1 because that's when we published it, but I'm actually going back to change it now, so it's just session 1. Take all the time you need. So this is an intro video of me describing what we're going to be doing, what the activities look like, what are the main concepts for the week. If you don't care, then just skip it. You don't have to watch this. This is just if you want to. All right, the next thing under every single parent video is the most important document for the entire unit. This is the assignments outline for this study unit, just for this 1 week. Okay, so week 1, you come here. We say, all right, beginner, intermediate, advanced. We have 3 different levels. Beginner means this is a new topic. We are introducing it 1 step at a time. There's a workbook you're going to click on that you're going to download, and you'll work on the workbook with me during class. Okay, and the recording is already up. The second one is a little usually a smaller assignment. Okay, intermediate. Intermediate students are students that already are familiar with the concept, but they need a little bit more help, and they don't understand. It's like the beginner is the training wheels. Okay, and then the intermediate, we're taking the training wheels off, but we're still there to help you balance. And so we're attacking the concept, we're looking at it in different perspectives. We're introducing some word problems. We're looking at it in a little bit more depth. And then once your student has mastered that, they can go on to week number 2. If after week number 2, they can go to week number 3, week number 4, and work their way through it. When you're done with fractions, you circle back to week 1, and now you start with advanced. Advanced is all the practical application pieces. We're already assuming, though, that you understand fractions. You can add, subtract, multiply, and divide fractions. If that's true, then as an advanced student, you can just start right there with the practical applications. These are where all the math labs are. Here, I'll even show you what the labs are for this week. So let's go back. Let's go back. Okay. And so the beginner class, this is the recording of me teaching the live class. So you can just push the recording. You can slow me down, speed me up, fast forward, rewind, have me say the same thing 5 times. And so you go through that at your own pace on your own schedule. So you don't have to do the live classes at all. Everything is already recorded. And then there's a workbook that you can do. The workbooks look like this. They're between 30 to 40 pages each, and we can click on one. I don't recommend printing out the answer sheets just because it's a whole lot more paper. You don't even have to print out the workbook. You can just have the students look at it and then do their writing in just a regular notebook, and that could be their math journal. If you want to print out the workbook, you can. The workbooks have things to circle and add and so forth, and have pictures, and sometimes they have puzzles and games and that sort of thing. So the workbook is very step-by-step. For the fractions, I might print this one out just because of all the shapes that are in there. Okay, and then what do is now we have more lessons. And then the intermediates section is right below. This is me teaching the intermediate stuff. Okay, and then all the recordings are there. And then we have activities. So all the puzzles, games, activities, projects, excuse me, those are all in the intermediate section. So beginner, we're just doing the workbook and we're just introducing the topic. Intermediates, now we get to roll around with this and have some fun. So you are actually going to design an ice cream shop. Excuse me. And so this is an activity where I walk you, you download the ice cream shop activity. Okay, it looks like this. And now, step by step, there are videos of me walking through every page of the ice cream shops. So you're going to have root beer floats. You're going to have some popsicles. Do you want a waffle cone or a regular cone? How much is that going to cost you? So, and all of that's in there. And then there's step-by-step instructions of me walking you through this entire workbook. Okay, so we're doing the whole thing together, just like we did in class, and we're coloring things in and we're figuring out what things mean. Okay, and then there are scavenger hunts involved, and there's dominoes. You want to see what the advanced class is doing? All right, so once you've worked through all of the 7 blocks for beginner and intermediate, now it's time for some advanced things. So advanced lessons, I actually walk step by step. We have an advanced live class that I walk through as well. And then a math lab, okay? So for example, we have a photograph of some whales. So this is a real aerial photo. And we want to know, how big is the baby? Okay, and we are doing that with fractions by looking at ratios and scaling up, scaling down. How do you find the scale of a photograph? How do we do one reference the other? So these are all practical applications. This is a condor. So we have a photograph taken. We went on a nature walk. We took a photograph. How do we know how big the wingspan is, right? So this is a real practical example. These are biology examples for this week. Sometimes we do chemistry, sometimes we do physics. A lot of time we do astronomy because that's really fun. But now we're also doing it. What happens if your picture is cut off? How do you figure that out? And so there's a lot that goes into this. And we have some astronomy, how big are planets, about the sun, the moon, and the stars. There's a lot of fractions. You can see fractions showing up here. And so, and what about galaxies? Okay, and we talk about that and how do we do conversions and so forth. So all of these practical applications are for every single week, for every single session. So every week I teach live. You can participate. If not, the recording's always there. And you can download all the handouts you want to do. How do I put this? It's not a checklist, it's a menu. I'm giving you a buffet. You come up and you say, I'm going to do the scavenger hunt this week and the ice cream shop. That's what I'm doing. So you pick and choose the ones you want to do. You don't have to do all the projects to understand what this stuff is, okay? So you don't have to do every page in the workbook. Even I say this a lot during the workbook. I'm like, okay, here's your page of problems. Do at least half. Are you comfortable? Not yet? Okay, now let's do a few more. Okay, how about now? How are you doing? So we're always checking in to see how your student's feeling about things like this. Okay, and then we always have, just for fun, do you know how we did the 2 math challenges? We did the sweater, the inside-out sweater, and we also did the handcuffs. Every single week, we have a math challenge. And so sometimes it's related to what we're talking about, like this one, the one with the flight around the world. Sometimes it's not, and it's just fun. Like we had the binary puzzle, and we just did a no left turn maze. And so we had some fun puzzles like this. The purpose of the challenge is to get you up and communicating and talking about your math ideas with other people. And they don't necessarily need to know the same level of math you do. But being able to communicate all your great ideas is a really important part. And it also helps students think through things rather than just being glued to a piece of paper the whole time. They're actually up and they're physically doing things. It's like a mental reset, and they get to use different parts of their brain. That's important too. So every week you'll see a math challenge as well. How is that for the world's longest math class? We're at 2.5 hours right now. Okay, so I hope this helps answer questions. So this is what the math program looks like. Let me answer the question, what if my kid has had some fractions, but I don't know where to start them? Good question. When you go to the math program, click on workbooks, click on whatever subject you want to do. So we have it for fractions and decimals and percent and algebra and geometry. Okay, so pick whatever one you want to work on. Say they've had some fractions, but you're not sure if they've had, or here, we'll do decimals so you can see that. Say they've done some decimals, but not a lot, you're not quite sure. Go to the last 2 pages. So scroll all the way down. There's a practice test at the end. It'll say either review or practice test. Have them take the 2-page practice test at the back. If they can do it, no hesitation, they get it, then they've tested out of the workbook. Okay, so every workbook has one of these. This is an easy way to do a little placement test. You can even have them read the problems to you and explain how they're doing it so you can better understand how they're doing that. And so, yes, so that is a way you can do that. We have workbooks for every single week, for every single subject and topic. Okay, how am I doing on answering questions? Yeah, so now we're at 1,600 questions. It's not going down. Do kids have to work through beginner, intermediate, advanced before they move on? No. So it's important that kids work on multiple areas at the same time. So I would say start with fractions. When your kids have had enough of fractions, then stop and then start decimals. You can always start at the beginner level of everything. That includes geometry, that includes algebra. So you can always start at the beginning and you take it as deep as you want to go. So if your kids are, I have kids that have been on the live classes every single time, and I know they have not completed all of the work for that session from last week, but they just want that interaction in the live class. And they can always join the beginner class. The beginner class is always available to anyone because it starts at ground zero. Every 7 weeks we reset. So it's not like when, like if you're running with a group of people, you know that the fast people in the front, the fast men and women in the front, right? It's like goodbye, right? If you're one of the slower runners like me. But like in a swim team, what happens? So they go out and back, and maybe for every out and back they do 3, you do like 1 lap. And that's okay. Then you're always starting again. And that's how we do it. So everybody's going to start at the beginning. More advanced students will go faster, and we have plenty of work for you. The beginner students, you need more time. And I want you to take that time and not feel rushed because that's where you are right now. That's okay. And so those students will take their time because slow is smooth, and then smooth will become fast. And so I want you to take your time. We want this to be a positive, happy experience. Somebody's asking, how much math should my kid be doing every day? I would say as long as they are happily enjoying it. So what does that mean? That means that they are, if it's 5 minutes a day, then that's enough. And then maybe next week you can bump it up to 10. And if they're still happily enjoying it, that's great. Following week, maybe it's 15. Because remember, we're after the long game. We're not cramming for a test. We want the kids to enjoy this. And if they're enjoying it, they're going to come back for more. And when they come back for more, those sessions are going to be longer. And by the time they get to high school, it's going to be no problem. You're not even going to have to ask them to do their homework, not even once, because they're going to be so excited about it. I mean, what would that be worth, right? Your kid can actually, can I tell you one more quick thing? So yesterday I was working so hard, and I have a high schooler. I have one kid who's in college who's actually watching me right now. Hi, he's helping run the back end, and I had 2 younger students, and I was working so hard last night working on this to get this class ready for you. They not only finished their homework, completed everything they needed to do, they made dinner, and they cleaned up the kitchen. And I didn't have to even say a word. So I just want to say to my family, thank you. So yay. All right. So if you are excited to have your kids join me, then now is the time to click the button. It's about to go away. We are ending class now. So, and if you are so excited to join me in math, I am excited that you're a part of it. Welcome to our math family. I will be sending you a welcome email and a hey, how to get started. If you have any trouble in the beginning with your account, send me an email right away. I usually answer within an hour or 2. If I don't answer, something's wrong, let me know right away so we can make sure that everything is working right for you, okay? So your special price today, remember, it's not $350, it's not $1,387, it is $87. And again, you can split that into 6 monthly payments of just $16 every month for 6 months. And we're happy to do that for you as well. And then somebody's asking about siblings. Yes, so make sure it's 1 enrollment per household. So if you have 2 kids in the same level, only get one, okay? Only get one, because it's one enrollment per household, okay? No matter how many kids you've got that are participating. If you have triplets, absolutely, we're happy to help. Okay, so go ahead and click the big button to get started now. I look forward to working with you and your child. If you have any additional questions, pop them in the comments section right now or send me a personal email, aurora@superchargedscience.com, and I will see you in math class. Bye-bye, everybody. I hope you had a good time. Bye-bye.